Testing. Oh, okay. You can hear me. Then I gotta go. What do I do? I go. Click. Oh, here we go. Right. VB2. B2. Okay. So B2's here, and B2 has to take in Discord and this, and then B1 takes in those, and B1 goes here to there. Okay. Okay, so let's try this. Okay, welcome everyone. Let's see. Yeah, feel free to type me a question or join the Discord. Either way is fine. And let me see. Oh, I gotta switch my bookwork. Okay, there we go. Okay, and then so that's showing. That's showing. I'm on there, and I'm also on real time. Oh, go live. Episode 5. Okay. Okay. So that's live. Okay. Well, everyone. Thank you for joining. Feel free to ask me questions. I'm trying to stream live on YouTube and TikTok and Instagram. So hopefully that's all working. And I've linked up the audio of TikTok and Discord. So in theory, if someone joins the Discord, they should be able to talk to me. And if someone joins the TikTok, they should be able to talk to me. So the Discord. Yeah. Should mute that. And yeah. All right. Sweet. Everything seems to be working. Oh, I gotta move that over a little. Okay. What's your view on dark matter and dark energy models, as there seems to be controversy whether the models need to be remodeled? Yeah, they may need to be remodeled. The James Webb Telescope has certainly given us a lot of insight on those particular things. More so the dark energy. That's the really challenging one because the dark energy is, you know, It has to do with the distance between galaxies and how quickly they're moving away from each other, and those are very difficult calculations to do. So the dark energy, I think, is harder to resolve and calculate. The dark matter, that has to do with the concentration that we see within a galaxy, and the concentration of gravity, I should say. And so that is an absurd claim. Like, if you were to claim that there was no dark matter, you would be basically saying, well, there probably isn't. We've probably found all the fundamental particles, and it's like, yeah, that's highly unlikely. There probably are particles that don't interact with gravity, and they would be incredibly, or sorry, they only interact with gravity. They don't interact with the electromagnetic force, and it would be a very strong stretch of the imagination to think that there are no particles that don't interact with the electromagnetic force, right? That would be an absurd thing to say. So like dark matter kind of has evidence of just like we're clearly not the smartest things, right? Meaning that we don't know everything, and clearly we haven't found everything. That seem like a silly thing to say. So dark energy just kind of has, dark matter has evidence towards what it is we know and don't know. What is the topic of the debate? Whatever people want. If you want to come debate me and join the Discord or join the TikTok, come chat to me about your favorite thing. If you don't want to join, you can type me a question. If you want to type me a question, I'll answer it as best as I can. Mm-hmm. No sound check. Check your mic. What do you mean? Of course you can hear my mic. Why would you not be able to hear my mic? Not you guys. The TikTok's telling me it can't hear me. So I'm like, what do you mean? No, I think it just was doing an alert thing. If I turn that on, is that going to be okay? Or is that going to do something weird? Let me just turn that on. Okay, that is working. Hello. If you're joining the Discord and you'd like to chat, just raise your hand in the Discord. If you're on TikTok and you'd like to join, just do the join thing on TikTok. Hello. Hello, Close. How are you?
Oh, hello. Right. You're up for questions?
Yeah, whatever you'd like to chat about. Mm-hmm.
Okay. Can I just get my thing?
What thing?
1 second. Wait.
Sure,
my headphone.
Sure. Yeah.
Hold on, putting on my headphones. Alright. Nice to meet you.
Nice to meet you.
So, it is quite late for me, so try to, I just wanted to know, so there's 2 things I'm interested in.
Mm-hmm.
So I am interested in, I'm more of a philosophical person rather than a math person in physics, but I'm always intrigued by the idea of math and the existence of math. Yeah, so, I mean, I could ask the big question, the question that has been like, owning my life, or like it's always been on the back of my mind of math. Okay, I'll just go with the big questions. Yeah. So I've always been interested if math is a pre-existing nature in the universe until it is discovered, regardless of which species learns it, if there's another planet in the universe who learns math, it won't be the same language and form of ours, but it still
Sure, sure.
relies on the same structure.
Hmm.
Or um, or if math is something we invented to describe the universe, you know.
Yeah, no, that's an excellent
Uh,
question. The quick answer is we don't quite know. So there's a lot of intuition, right? That math seems discovered because it seems like there's intrinsic properties of the universe that are like fundamental in some way. It's very hard for
mhm.
us to crack down on exactly what that means because anytime we try to get really specific, then a lot of our theories start to fail in different capacities. So, like, even our most precious theories of mathematics have can get overturned depending on where you look in the universe, right? And so, of interest is like something like propositional logic, right? In propositional
Mhm.
logic, we have like the statement P or not P is always true,
Mhm.
meaning a statement is always true or the negation of it is always true. I mean, assuming it's a binary statement that has a truth value, you know, something along, some whatever caveats you need, right? Um,
Yeah.
and that feels incredibly intuitive. It feels incredibly intuitive that every time we come across something, either it's true or the negation of it is true, right? Um,
Yeah.
However, when we go to quantum mechanics, technically that property's true, as far as we know, but certain consequences of it don't appear to be true anymore. And we've done this experimentally over and over and over again. So, for example, maybe you know De Morgan's law. If not, it's not a big deal. But there's a
No.
particular law, De Morgan's law, and De Morgan's law is a tautology. It's a fundamental truth of propositional logic, right? We know that it's true, you know. Well, De Morgan's law is false in quantum
Yeah.
mechanics, right? It's experimentally false.
Okay.
And so
Is this some ancient thing?
De Morgan's law, it's very old, yeah. But I mean, it's not that
Yeah.
old. But it's just the statement that ands and ors distribute over logic.
It's not like the Murphy's law or something. It's more like as big as Isaac Newton discovering, you know, things.
Uh, Isaac Newton. Um,
Like basic things that change the course of history, and then there's other laws that people call have you heard of Murphy's law?
I probably have, but I don't remember it off the top of my head at the moment. So
It's
you'd have to
like
remind me.
and everything that can go bad will go bad. It's not something that
Oh,
you
oh,
can like. Okay, it's
yeah.
not like that.
So,
All right.
so De Morgan's law is like P and Q or R is
Okay.
always logically equivalent to P and Q or P and R. And
Hmm.
this comes out as a tautology, meaning that under a truth table, you get all T's. Like no matter what P and Q are, you get T's for this, right? So this is a
Yeah.
proven true theorem in propositional logic, and it's false in quantum mechanics, right? So
Okay.
that's hard to wrap our minds around because our minds are so um, positioned to think of like tautologies as like unbreakable, right? And
Yeah.
yet, well, we have a tautology that breaks, and it's not the only one. There's other similar ones, but um, so the point is that like if you try to tell me, hey, there's something in mathematics that's guaranteed true in the universe, I'd be like, well, like what? Like what
Yeah.
statement could you give me that I know 100% is true? And it's like, well, we've had lots of things that we've really thought were like 100% true and they've turned out not to be true. And honestly, it sort of makes sense now, right? Like just think of just think of like a black hole or something, right? Like you tell
Yeah.
me 1 + 1 = 2. And I'm like, yeah, I believe
Yeah.
you. Look at the world. It looks like 1 + 1 = 2. Of course it does. Like it's
No.
obvious, right? But then we fall into a black hole where literally space and time swap places and gravity does a bunch of crazy stuff.
Yeah.
And like, you tell,
Yeah.
like, if you tell me 1 + 1 = 2 inside of a black hole, I don't know if that's true. Is that true? I have
No.
no idea anymore. Maybe it is. I have no idea, right? Like, it's too hard to, um, you know, um,
But may I ask a question?
yeah, yeah, of course, sorry.
Are there, are there more fundamental math things that I know that when we think of, I've seen a lot of movies, and then they say like, oh, we're trying to find the equation of a black hole. It will tell us everything we want to know. And then
Mm-hmm.
there's 1 + 1 = 2. That's is there? Do you think there is an equation that is fundamentally true, and then the more you try to break it down into 1 + 1 = 2, then it gets kind of hard to grasp. I mean, not hard to grasp, but it gets kind of English is not my first language, but it gets kind of unreliable because we're just diving into a specific thing and explaining it in human terms. But then, do you think there is a fundamental, let's say, equation that is true for everything?
I mean, I wouldn't know what it is. So we could hypothesize there is, right? Like, for example,
Yeah.
maybe there's a theory of everything, as we might call it,
Oh yeah, yeah.
that tells
Stephen
us
Hawking.
how gravity works and tells us how everything works in the entire universe. And it's fundamental, meaning that there is no ability to improve this algorithm. It is actually what defines the way that the universe works, right? Like, that would be
Yeah.
interesting if there was such a thing. There appears to be evidence of convergence towards such a
What's
thing.
that?
Convergence is when you get closer and closer to approximating something,
Mm-hmm.
um, but you don't actually get to it literally, right? So, like,
Yeah.
in other words, we come up with theories that get close to approximating a theory of everything, but we don't
Yeah.
have a theory of everything, right? And so the convergence itself, one could argue, is evidence that there is a theory of everything. We just don't know what it is yet. But it could also be
Yeah.
the case that there is nothing at the end. It's just that we're getting better approximating our previous results. And so those are just getting more and more accurate. And there is no, like there's like a singularity at the end, and the only thing you can do is just get closer and closer to the singularity. You can never reach it, right?
No.
um so we don't know, right? So
I mean,
yeah.
that's kind of, kind of how I said earlier that math is a way to describe the world,
Hmm. Certainly.
um, and not, y- yeah. Um, I also think it's interesting with the information, how information comes into this.
Hmm.
Um, but I don't know. Maybe I'm taking up too much of your time. Maybe someone else should speak.
No, no one else has raised their hand or anything. um
Oh, okay. Yeah, I don't know how you work this out. Okay. Well, um, yeah. So, math. Um,
sure.
math exists. Yeah, sure.
Hmm.
Math exists in our world to describe things. Otherwise, we would,
Eh,
you know,
yeah.
act. Yeah, you get what I mean. Um, and also, I might add that I hate math. I despise math.
Okay, yeah,
I
no
a-
worries.
and it just makes me frustrated. But I think it's very interesting what lies behind it. So there's math, and would you say that math holds information?
um
Is that
I
thing on your
guess.
paper? Is that information right there?
Oh, this, certainly,
Yeah.
yeah.
Okay.
Hmm.
Um, So I want to know, what is information?
Sure. So there's several descriptions of information, right? I
Hmm.
think the easiest way to think of information is like ones and zeros, right? Like in a binary sequence.
Yeah.
Um, Everything we deal with, especially today, is in terms of ones and zeros because we store things on a computer. It's also how we like process information, like when we process light waves or whatever. Those are going to be converted into ones and zeros and stuff. So that's kind of how we think of information, right? Um, in some sense, information is equivalent to energy, and there's a
Yeah.
thought experiment that was done by what is it, Maxwell, right? So Maxwell came up with his
Hmm.
concept of a demon, Maxwell's demon. And
Yeah.
so his concept was if you have a bunch of particles bouncing around in a chamber, and the demon knows which particles are hot and cold, and the demon has the ability to um, turn off and on a barrier that would keep particles on one side or the other, then the demon would be able to theoretically, separating the molecules and then allowing them to bounce around and separating them, right? Theoretically, the demon would be able to separate all of the cold molecules from all of the hot molecules without touching them,
Yeah.
right? They just bounce around and they would be able to the demon would be able to separate them, right? And this,
Yeah.
of course, creates a bit of an issue because this means that the demon can reverse entropy, right? And
Hmm.
theoretically, the demon didn't introduce any energy into the system. And this would suggest that, energy can effectively be created, right? By
Yeah.
thought alone, right? And so
Hmm.
the conclusion, of course, is that you can't create energy out of nothing, right? And
Yeah.
so the way to
That's right.
resolve it is you conclude that it must have it must have taken energy for the demon to process the information that the demon had. That's the only conclusion. And that means
Hmm.
that we literally have an equation where this amount of information must must minimally create at least this amount of energy, right? Like so
Hmm.
there's a relationship between literal information and the energy, right? The energy that it
Yeah.
can create. And so information itself in some sense seems to contain some amount of energy in it, some amount of heat in it. um,
You'd say, uh, you'd
yeah.
say that information is data, and
Sure.
this data can hold energy, or
Yeah, yeah. But I'm meaning the arrangement of it. Like if you gave me a
between
if you
them.
yeah, like if you gave me a jar of
Yeah.
if you give me a jar of electrons and they're just
Yeah.
mixed, that is going to have a different level of energy than if they're separated into some hierarchy. Right? That will necessarily have more energy in it. How you extract it out, maybe we don't know, but it will have to
Yeah.
have some more amount of energy because there's more information in the system or less information or whatever, right? Depending on how we
Yeah.
measure information. And so the point is that it seems the universe requires information to somehow have some type of energy in it, even though the very concept of information is really just an abstract way that we formulate um, like it's a representative, right? We are representing something that's happening with ones and zeros. It's completely representative. Like ones and zeros aren't floating around in the universe and we're not collecting them into a string or something. It's a thing we made
Um.
up. We made up the language of ones and zeros, right?
Yeah. Because when you said
Mm-hmm.
the universe requires information, that kind of sounds like there would be some higher being gathering all this information, like it has some kind of purpose. But when I think of math, I think
Mm-hmm.
the distinct distinction. That's quite a weird phrasing, but the distinction between them is that math is actually there and it's working in itself in as a structure to the universe rather than information that is, you know, I don't believe in God, but taking it in, the universe taking it in, processing it,
Mm-hmm.
having the data, and yeah. So I think there's a difference in that.
Yeah, there could be. Yeah, there could be. I don't know. Um,
Okay.
uh, I'm not aware. Like, so I only process stuff up to the information I have available to me. So it's kind of like
Yeah.
it's like going back to the singularity thing. Like, are there any absolute statements in the universe? Right? I don't know. I mean, maybe like is 1 + 1 = 2 an absolutely true statement? Maybe, I don't know. At the moment, I
Hmm.
have a lot of evidence that math has kind of, you know, failed to describe everything in the universe at times, but then other times it's really useful. And so I just take it as is. It's really useful
Yeah.
sometimes, and sometimes it's not very useful, and that's all I know. So if it's fundamental, that would be cool, but I'm not sure how we would be able to demonstrate that, even if it was. Like, how would we convince ourselves that something is truly fundamental? I'm not sure.
Yeah.
Right?
I don't think it makes it worthless anyhow.
Certainly not.
Having it.
No.
Yeah.
Yeah, we make stuff meaningful to us, right?
Yeah. But it also applies. It brings evolution further. It brings us out in the universe. Someday we're going to build rocket ships that you know can align with the with space. And yeah, it's just. I also thought of information about black holes. Information gets deleted in black holes in singularity.
Mm,
Um,
in
so I
there,
don't know what to do with the concept that information gets destroyed. It's
well,
kind of
yeah. So, as far as we know, there is no such thing as information being destroyed, and we kind of take that as a principle. We're pretty sure there's no
oh
such thing.
yeah, from outside it's gone forever from the outside.
Well, we don't know that, and so,
Really?
well, no, it depends on the model that you're looking at. So we
Okay.
believe that information doesn't get destroyed. We think that that's the case, and
In the
one of
context
the
of black holes.
in the context of black holes, yes,
Yeah. Okay.
and one of the people that did a lot of work in this was Hawking, right? Who
Mhm.
he was trying to figure out how do we prevent information from being destroyed, and he came up with a concept which is, well, it must be that black holes are radiating, and he developed his concept that is now known as like Hawking radiation. And so there's
Yeah.
this thought that like black holes must actually be radiating, and the
Mhm.
radiation that they're exhibiting must somehow contain the information of the stuff that falls inside, and that would be a way to resolve the idea of information getting destroyed. Right now,
Okay.
there's a little bit of difficulty that occurs there. So there's something called the holographic principle. So
Mhm.
the surface of a black hole is technically two-dimensional because it's a surface, right?
Yeah.
And you would imagine that if the surface was capable of radiating all the information that falls into it, then the
Mhm.
radiation has to be exhibited from a two-dimensional surface. However that happens, we don't know how it happens,
Okay.
but it must happen like that if it does it that way at all. Well, that leads to a little bit of a problem because that means that if I throw a chair into the black hole, the chair's info somehow like sticks to the surface, which is now available to radiate out later, but the chair goes in, as far as we know it's gone, but the information of the chair is somehow available to the surface. But the chair was
Okay.
three-dimensional, and the surface was two-dimensional. And
Yeah.
so that means all the information that made up the chair must somehow be available to a two-dimensional surface, right? And there's a name for
Okay.
that, right? The name of, here's all the information I have for a three-dimensional object, but I'm going to project it onto a two-dimensional surface. The name of
Mm-hmm.
doing that process is called a holograph, right? And so,
Like a
um,
projector?
sorry, what?
Like a projector?
Yeah, right? Like projectors
No.
project
Okay.
movies, right? And it looks like there's three-dimensional things in the film, but you're only seeing a two-dimensional surface of it, right?
Yeah.
And so that's an example of a holograph, right? Um,
Mm-hmm.
and so the point is that um, if this is the case, there's certain issues that arise. Like, so there's this theorem in mathematics that if you take like a three-dimensional cube, there is no continuous one-to-one onto deformation of a three-dimensional cube that turns it into a two-dimensional square. So you can't take the cube and turn it into a square and preserve one-to-one onto and continuous, right? That's not possible to do. So that's mathematically
Okay.
impossible. And
Okay.
so that seems to suggest that, well, if we can't do that for any three-dimensional object, we can't do it for we can't do it for all of them because we have a math theorem that says that that's not going to happen. Then the conclusion is, well, maybe not all three-dimensional things are possible, right? And so
Mm-hmm.
and that would mean that we may be actually two-dimensional things in a smaller dimensional universe, right? And
Yeah.
everything we're looking at is just a three-dimensional projection of that two-dimensional stuff, right?
I've heard this before.
Yeah. And all that would mean is that not every three-dimensional combination we can think of is actually possible. Only some of them are possible, right? Now we don't know how to prove that or anything, but yeah.
Yeah, and it also goes further, right? That we might be three-dimensional, but we could also not get the viewpoint of being four-dimensional, which is when
Uh,
I think it is four-dimensional when everything, when your whole life is bent. Everything
no.
that's ever happened is bent. No, you haven't heard of that?
Well, I was just talking about everything excluding time, but time is the fourth dimension. So, like going through time
Oh yeah.
is the
So,
fourth dimension.
hmm. Yeah, a black hole is the only place in the universe. Uh, a black hole, or the singularity, is the death of time. I think that's what Brian Cox said. I was listening to him.
Sure. Yeah.
uh,
Yeah. Brian Cox is good. Hmm.
yeah, I saw him
World
live.
Science Festival.
Yeah.
Oh, that's Brian
Uh,
Greene. Is that Brian Greene?
Brian Greene.
Brian
Isn't that
Cox. Sorry, Brian Cox is
art
the
history
guy.
guy?
Brian Greene? No, there's two physicists that are named Brian. One of them runs the World Science Festival, and he interviews people, and he's American. And then one of them is like, I don't know, not American, like British or Australian. I'm not sure. I think Brian Cox
Oh,
is
okay.
that one, right? Let
Yeah.
me double check. I'm gonna do a Google search here real quick.
Yeah, yeah.
Brian Cox. Oh, jeez. No, I have no idea who Brian Cox is.
You've
No,
never
I
heard
was
of
right.
Brian Cox?
No, I've heard of Brian Cox. I'm sorry. Oh, I'm sorry. Here, let me show you. Browsing. This is what it
Okay.
pulled up for me, and I was like, "Who
Oh,
the
yeah, yeah.
hell
I've
is
seen
that?"
him.
And I was like, "That's not who I was
That's what
thinking."
I looked
But
up
it
when
put it
I.
up here.
Yeah,
Yeah, this is Brian Cox.
yeah.
Yeah, I know who he is. Yeah, but I was thinking of Brian Greene. I think it is right. Yeah, Brian Greene. So he runs the World Science Festival, and
String
he
theory.
does string theory and stuff. So he does presentations all the time. He's written a bunch of books. He considers himself kind of a physicist enthusiast. He has a PhD in physics, though, so
This one, Brian Cox?
Brian Cox. I don't.
Or are you talking
think,
about Brian Greene?
Brian Greene, I know, has a PhD. Does Brian Cox have a PhD in physics? I thought he did.
He's a
He's a
professor
physicist.
in Oxford, I think.
Yeah,
Or is
yeah,
it?
yeah, exactly. Yeah, he's a professor of particle physics. So yeah, he's got a PhD in physics. So they're both PhD physics people, right?
Yeah, I have his book right here
Oh
about
yeah.
black holes. Yeah.
Oh, that's awesome.
Does work on black holes. Yeah. Yeah, I went to his show, which was merely about black holes, and he said that black holes are the end of time, which is something significant to the universe. I mean, yeah, that was a wrong word. But
Mm-hmm.
yeah, I'll just, it's almost 4 a.m. here, but I'll say that I'll end it with, yeah, I don't think, I might have heard this from someone else. I don't remember if it's my own thoughts, but my conclusion is that information cannot be deleted, even in a black hole.
Yeah, we
Uh,
assume information can't be deleted. We're pretty sure that that's true, that information can't be deleted or destroyed or whatever, and
yeah,
that's why
because,
we have.
I think that it's going to come out the other end, of the black hole. Maybe into a white hole, maybe to another universe.
Yeah, but even as we would still think that in our universe that information can't be destroyed. So if you were to make the statement, oh well, maybe it goes into another universe, like our own universe, we have a tendency to think that all the energy of the universe is fundamentally in some way neutral, right? And so if there was places where gaps of energy were like leaving, that would also violate our own universe's information and entropy. So it's an interesting thought on whether or not there's like another universe in a black hole, or if we're in a black hole. We don't know.
Oh, Brian Cox said we could actually be falling through a black hole right now and we would not notice.
That is
Uh,
true. The whole universe that we're in could be a black hole. That's a possibility, right?
oh, yeah.
and
Yeah.
it's a classic calculation. Just calculate the Schwarzschild's radius of the current known observable universe, and it comes the calculation of it comes out to effectively, it's off by a little bit, but effectively the size of the current known observable universe. And so the size of the black hole we would be in if we were in a black hole is about the size of exactly what we see, right? So,
Yeah.
yeah.
Yeah. There's also, have you heard of, I don't remember, I saw it, yeah, Brian Cox spoke about it too, but I also saw it like on Instagram a few days ago. Um, I don't, it's basically, have you heard, you draw a map of a black hole and it kind of looks like a two-piece triangle, like I don't know what the shape is called in mathematics.
Mm-hmm.
It's like a cone and then a cone down.
Yeah,
But yeah,
it's just called a cone. Mm-hmm.
but a cone has an end like a triangle, right?
Hmm?
Maybe. Yeah, let's say
You
it's
mean
a cone.
this thing, right?
You're screen sharing right now.
Yeah, sorry. Hang on. You mean this thing, right?
Uh,
That's called a cone.
yeah, I mean, if you try to do two lines, like the two first triangle lines, like
Mm-hmm.
one up, one down. Okay, maybe this is
Two,
pointless trying to make you draw.
two triangle lines.
Like, okay, imagine a triangle standing up.
Like this.
Yes, but instead of that line that connects it at the bottom,
Mm-hmm.
there's two more lines that go down
So
and
a
connects.
diamond, like this.
Yes.
A diamond. Okay.
Okay, actually, I don't remember if it was a diamond or a triangle, but let's say it's a triangle.
I
So there's
think
a triangle, and
I think you're thinking of this diagram, right? Right. And
Yeah, and then it
the
keeps going, and then you add on to it.
yeah, and so the angles represent speed, and so this is the angle of the speed of light, right?
Okay.
Speed of light. And so these are called light cones. The light cones. So
Okay.
they're not. It's kind of a misnomer. They're not cones because it's two-dimensional. They're like light triangles, but they call them light cones. So that's the person that named them. I don't know who named them. Right? Because a cone is three-dimensional mathematically, but physicists don't listen to us mathematicians. So
All right. Well, there's okay, whatever it is. It's Can I send you a picture
yeah, you can post picture in
in
the
the
side chat.
chat?
Yeah, sure.
Yeah.
Oh yeah, butterfly gave a nice picture. Yeah, that's a light cone.
Oh,
Yeah. Yeah, exactly.
this
That thing.
is
Sorry. Oh, okay, okay.
yes.
So, okay, fine. We
So this is the one to the right is a map of our universe, and let's say there's a
okay.
black hole on this right side.
Mm-hmm.
Um, or yeah. The line. This is very complicated. You got one of those in your lap? How?
What?
Okay. Um, so I think the line is the singularity. Or anyway, the thing shows that if there is such a thing, then there's a black hole that it just shows that there are possible other universes because of
Well, all that's being, I mean, correct. What is being presented here is a pictorial description of
yeah.
trying to satisfy Einstein's equations of relativity, and in
Mm-hmm.
particular, right? If you continue across the black hole's event horizon, then it is suggestive that there's possibly another universe on the other side, right?
Mm-hmm.
um we don't know if that's the case, right? It's just that it's consistent with the equations, right? And that's what this picture
Okay.
is demonstrating. The picture's demonstrating that there's a consistency there. The
Okay.
thing that the things that break down that people are concerned of course, we don't know that there's another universe, and we're not sure how we would demonstrate that, and we've never seen a white hole, right? So if you've
Yeah.
never seen a white hole, then it might be that this is breaking down. Like if one day we looked out in our telescopes and we saw some region of space that was just spewing out material, that would be incredibly strong evidence that there are white holes. They do exist, right?
Mm-hmm.
And that both sides of this equation are actually realizable and possible. But if white holes are impossible, then this diagram starts to look less secure, right? As far as
Okay. So this is
interpretability.
just pre-assuming that they do exist and to explain how it will look like.
Yes, yes, correct. Yeah,
Okay.
yeah. There's
Okay.
no, well, but that's what happened before. So black holes were discovered before we found them in space, right? Einstein came
Mm-hmm.
up with theory of relativity. Other people found solutions in them that would suggest that there exist regions where gravity is faster than the speed of light, meaning that gravity is so intense that nothing can escape, not even light, and that
Mm-hmm.
in theory there would be nothing in physics that would prevent the collapse, and that it would in theory collapse down to a singularity. This was hypothesized and published about. People didn't know if it was real. They were like, you're telling me that I think the first idea of it was called a dark star, if I remember correctly, which was the idea
Okay.
that there might be stars that are so dense not even light can escape them, and so you wouldn't be able to see them. But then they were put. But I think that was before Einstein's equations when they were talking about dark stars. But then with Einstein's equations, it was seen that they would they would do more than that, right? They would mess with literally space time, and they would collapse into a singularity. And so they were, I don't know who coined black hole, but this was one of the things that was published. And then we found them, right? There's a supermassive black hole in the middle of the Milky Way. You can
And this
literally
is the one we discovered it. We knew that existed because of that one photograph, right? Or
no. We took two pictures of
no?
a black hole with the New Horizon telescope. We know that the black hole in the center of the Milky Way is there because we took images of all the stars rotating around it. There's like
Oh yeah,
there's
yeah,
like
yeah. That's right.
yeah, there's 80 stars or so that are like rotating like on 6 month cycles or something. They're flying really fast. Like in terms of like
Mm-hmm.
speed, those things are moving insanely fast. But the thing that they're going around, we can't see it. It's black, but we do know how big it is because we know how much mass it has because when you look at the trajectory of things going around it, you know how much mass they're going around. Like what are they orbiting, right? And so we know
Yeah.
the mass of the thing in the center that has no light. And then we took a picture of it. We used the New Horizon telescope and took a picture of it. So we literally have a
But
picture of it.
that one has actual uh, mass going inside it. Doesn't not?
Well, I mean, I guess somewhat. Technically, I would imagine all black holes are eating something at any given point. So, um,
I don't think so. I mean, there's black holes out
uh,
in the vast universe with completely unbothered, and they're just waiting for something to pass by, but they never do, and they're just black and non-visible.
that
Just
that maybe, but that's not. So, black holes have incredibly strong regions around them that are hard to wrap our mind around. And every black hole probably has an accretion disk of stuff that has been ripped apart and is swirling around it in like a ring-like fashion. It's also absorbing all the light of all like the stuff that it's destroying. And so
hmm.
you to see it, you have to zoom in so far. You have to zoom in like you're looking for like a little grain of sand on the backdrop of, all the other stars, right? And
Hmm.
so they're, um, black holes are very, very. It's most like it would be incredibly unlikely if a black hole literally had nothing around it. It most likely has all kinds of stuff orbiting it all the time, right? Yeah, yeah.
Hmm. That's I've never imagined that because the universe is so big. I don't know. I just thought it was. I don't know. Maybe it's an assumption I had, but I thought I heard that it was known that
Mm,
uh
I,
it
there.
big. There's like pictures of like demonstrations of black hole that just that's the thing that's scary about black holes because
Mhm,
there's some just lurking there and you don't know until you pass by and you're just swallowed up. It doesn't happen instantaneously, of course.
uh-huh.
But but
I,
that they're lurkers.
Sort of. We see the light bend around them though, and again, anything. So like, if there's like a supernova
And that's like
explosion,
light from far away. It's not that they're being swallowed up. It's just light bending because it's in the way.
correct. But most likely they have stuff orbiting them too. Like there's probably light that gets caught in their orbit, right? Light itself
Like
gets caught in their
physically.
orbit. Yeah, yeah, physically. And then there's
Okay.
particles and stuff also caught in their orbit. There are certain regions where you will literally just be orbiting it near the speed of light around a black hole. And
Oh,
you really can't get away anymore. So there's regions where you can't get away from a black hole anymore, like it's just not really possible before you even cross the event horizon, right? And so
yeah.
there's regions of like orbiting and stuff that it can get very complicated. But the brightest things in the universe are quasars, and
Yeah.
quasars are black holes that have recently eaten a star and ripped it up into a bunch of little pieces that are swirling around it. And then those, because a black hole is spinning, it has its own magnetic field, and those will get caught and shot out of the top of the black hole like a stream, almost like it's
Because
literally
it's
a
full,
stream.
it doesn't want to eat anymore?
No, it's because some stuff is not going to fall into it, right? So some stuff is orbiting around it at like near the speed of light, and then it makes its way up the magnetism, and then it gets ejected out of the top of the black hole through the magnetic field, right? And those are quasars, and they are literally the brightest thing that we can see. They're incredibly bright, and they're not stars. They're literally parts of stars being ejected out of a black hole, not out of a black hole, ejected out of the outside of a black hole, right? So what I'm saying is the outside of a black hole is an incredibly violent location, and it rips apart stars, and it swirls stuff around it all the time. Like black holes just do that all the time. Anything that comes near them is going to get ripped apart and just is going to be orbiting and stuff. And some of that material falls into it, but others of that material literally just stay in an accretion disk, and some of that gets ejected out through these magnetic fields, right?
So what you're saying is a lot of black holes become quasars.
So, I am. I mean,
Or
quasars
if
are.
it does, yeah.
Yeah, I mean,
Yeah.
I'm not saying that they all do. I'm sure that many don't. Quasars, I think, are supposed to be like really, really big black holes, so they're not just your average schmo, right?
Yeah, yeah, yeah.
Um, but I imagine like every black hole is incredibly violent around its outside. It has incredibly violent regions where it destroys stuff, and it keeps that stuff trapped in orbits and things. And so it would be surprising to me for a literal like black hole that has nothing around it. A black hole like that might be more so categorized as a like a primordial black hole. Like it was somehow started, but it wasn't from a supernova explosion. There was no matter around it. There were no planets. It didn't come from a star. It had like it came about through the expansion of the universe at the very, close to the Big Bang, and it just is like some primordial black hole that's floating in space, not near any matter, right? But like your average black hole that's generated from a star, it's probably got all kinds of matter around it that it's like swirling and stuff.
Okay. So what you're saying is your definition of a black hole comes down to not it comes down to the violence of it.
I mean, they're certainly incredibly gravitationally violent. Yeah, absolutely.
Yeah.
Yeah, there's no question about
Okay.
that. Yeah.
Well, I have to go to sleep, but yeah, I love black holes are my I'm in love with them. Uh yeah.
Cool, cool. Well, thank you
But
for
yeah.
coming up.
Yeah, thanks for having me. I'm a big fan of your stuff.
Oh, thank
Do you
you.
usually like post?
I've been
Like,
posting on Instagram and TikTok and YouTube, and I'm trying to regularly post, and I do some debates here and there
mhm.
to try to deal with misinformation and disinformation stuff. So those go
Okay.
on the YouTube. But you'll probably see shorts show up on the Instagram as soon as I get around to getting the shorts
Oh,
done.
this conversation?
This conversation. So I post the lives on the YouTube, so you can go listen to this later if you wanted to. Um, but if I'm running low on content, I may cut up stuff into more explanations or something, and then it gets like turned into a short. But for the most part, these lives have just been going on YouTube as like a straight video, right?
Okay. Okay. Well,
Mm.
I'll be happy if it comes up on my feed. Uh,
Okay. All right.
thank you.
Yeah. Yeah. Thank you.
Goodbye.
Bye. Let's see. So some people asked some questions. Uh, what do you think of Eugene Wigner's paper, The Unreasonable Effectiveness of Mathematics in Natural Sciences? I'm not sure. I don't think I've read that one. That's why black holes need to be remodeled. Information can't be destroyed. The description of black holes has to be remodeled. Yeah, probably. Till next time, thanks for listening. Yeah, thank you for listening. There's a high probability that there is a black hole that does not have anything around it, has essentially come to a state of balance. If there is, I'd be happy to correct myself. I'm not. I'm not aware of that. It just seems like my understanding is, as far as we know, most black holes are created from stars, and so there's all this stuff around them all the time. And you can just do the math. Like, if I make a pin-sized thing that has a crap load of gravity, what is the probability of, like, me throwing a planet at it and missing? And the answer is incredibly high. But the thing has such high gravity, it's not just going to let the planet go by. It's literally as it gets close, it's going to spaghettify the planet and rip it into pieces and swirl it around. And so the odds of actually hitting a black hole and going inside of it are so tiny. It's much more likely a black hole is just going to rip stuff apart that comes too close, right? And then swirl it around for a really long time. Um, so, hey guys, love the content. What are we talking about? We're talking about whatever anyone wants to talk about. People want to, chat or ask questions or whatever. And no one's on the TikTok, but if you're on the TikTok, FYI, you can join on the TikTok too and talk to me. And the audio should be linked up, so you can chat through the TikTok or the Instagram. So if you want to chat through the TikTok, you can do that as well. Invite to speak. Oh, of course. Hi. Hey Zeno, how's it going?
What's up, Bobby? Good. How about
Good.
you?
Yeah, a bit
Good.
busy. Yeah.
Makes sense. Makes sense. Yeah. No, this week was super hectic. With I move into college next week, so
Oh
getting
yeah.
all the stuff done. Yep. 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 There's some good
Oh.
news about that. I'll tell you later. But
Oh. Okay. Okay. Sounds good.
yep. 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 Yeah. Okay. So I don't know if you want to look at that slide for God thing I told you about.
Oh,
Up to
sure.
you.
We can take a look at it.
Okay. I think it'd be easier if I just sent it to you and you pulled it up. So it'll just be a Google slide. Um, and this is not made by me. So if you have any, issues with it, I don't take offense. Okay, hold on.
If um if it's something that's really long, do you think maybe you might want to email it to me and I can look at it later? If
Uh,
it's a really long
y-
thing.
well, let's see. It is okay. So it's 21 slides, but I think the only relevant ones are like 17 slides or like 16 slides or something. Because the last ones are like why the Trinitarian God makes sense or something. So we don't have to look at those. Of course, we can just look at the arguments, but it's up to you.
Um, yeah, I'm just because if it's something that might require 5 or 10 minutes of reading, it might be easier if I look at it later. I think that'd probably be easier.
Okay, that's cool. I do want to go. I mean, if you want, we can look at one slide right now just to
Sure, sure, we can do that.
see. Okay, because I do want to hear. Okay. Um. So yeah, the first one. Okay. Let's see. Introduction. Blah blah blah. Yeah. Okay. This is like the first one. The reality makes itself real. One is the universe is the domain of being or reality.
Do you want to
Insofar, I
do you want to screen
with a,
share the PowerPoint or something?
I have it on my phone. I don't know how I could
Oh,
do
okay,
that.
gotcha,
Yeah,
gotcha.
yeah. I'm poor. Don't have a computer.
No worries.
uh, Here, let me see. I could put it in I could take a screenshot and then put it in the side chat.
Someone's saying that there are buttons at the bottom of the screen. The share button on the phone of your screen.
Oh, sure. I see. Yep.
Oh, interesting.
Okay, maybe, I think you can see it now.
Yes. Yeah, so I can pull that up.
Okay, sure. Yeah, so that
what happens
reality
if you
makes itself real.
If you turn your phone sideways, does it do
Oh,
it the other
okay.
way? Oh,
Yes.
beautiful. Look at that. That's amazing. Okay.
That's awesome.
Awesome. Okay. And
So yeah, that's the first slide.
so the universe is the domain of being or reality. Insofar as anything, it is part of it. There is no domain of non-being. All things, be they possible or potential, minimally are. A-R-E. Okay, sure. I don't know. There is determinacy, the distinction of one being from another in the universe. There are many things that are not each other. Okay, sure. I don't know. There is determinacy of determinateness to the universe, i.e., determinacy is distinct from the universe as unity. Okay, that's a weird thing to say, but sure.
Yeah. Okay. Yeah, I can provide support later.
Sure. Given P1, there is no other which determines the universe, for beyond it there isn't anything. Given there is no other which determines the universe, for beyond it there isn't anything. Okay. Given P4, determinacy cannot originate or be determined from another to the universe. Determinacy cannot originate or be determined from another to the universe. I don't know. Sure. What is within the universe is not other to it because it all expresses its unified being. Oh, I hate all this. I'm sorry.
You get it. It's okay.
Shows that all that is distinct, i.e., determinate. Experience shows all that is distinct, i.e., determinate. To be minimally, to be determinate, what cannot be determined is no thing. What? Oh my God, dude. What determines the universe to be what it is? Its determinacy is the universe itself. Blech! Okay.
Yes.
I can't follow, man. I'm sorry. I'm trying. I tried.
No, okay, so
I'd have to write it out. I gotta write it out with symbols or something. I don't know what the hell's going on. So there seems to be the person indicated that they gave me two definitions: the universe and determinacy. They then immediately screw that all up and give me 5 other definitions, which is determinacy and determinateness are apparently 2 separate words. Then define determinateness, because that was never defined. And then the second thing, every single one of these introduces a new term. There is no other which determines the universe, for beyond it there isn't anything. So now we got the word anything, we got the phrase no other, we got beyond, right? And I don't know what any of those mean. Determinacy cannot originate. So now we got originate. We're using originate. To be determined. Oh my God. So we have determinacy, determined, determinateness, distinction. It's too much. Distinct.
Yes.
Sorry. Now we have distinct. Okay. So we have distinct, distinction, determinacy, determinateness, determine, right? Determinate. Are these the same word? Are we writing sentences that mean the same thing? I don't know.
So anytime people had issues with, because I've seen him run the arguments, anytime
Uh-huh.
people had issues with the definitions besides those that were given, he would just say we're using them in a colloquial sense, so standard English applies. Besides the
Then why
ones
would
like determinacy and
I would
yes, I agree.
push back on that drastically. Like number 3 is there is the determinacy of determinateness to the universe. If those are colloquially the same thing, that sentence makes no sense, right?
Right. Yeah. Okay. So, uh, hold on. I'm gonna stop sharing my screen
Mm-hmm.
because let's see. Uh, uh, uh. Wait, no. Yeah, there we go. Okay. You can still hear me, right? Yeah.
Yeah.
Yeah. Okay. So that's pretty much the issues I had. He says like he's nice to me because I pointed out a few critiques. So once I criticized it and he made some edits, he was like, okay, this guy kind of knows this stuff. So he's nice to me, but I basically said the same thing. I'm like, look, whenever people like object, you just do the continental philosophy people thing, and you're like, oh well, you just don't understand. Like that was my main issue with it. Um, and to be fair, like he's well versed in Hegel, so he was like explaining it to me, and I'm like, okay, I guess some of those things make sense, but like if you're gonna accept this, you need to like understand Hegel and Spinoza, and it's like it's a tall order for like an argument that could just be like
And then
it could
so if you
go ahead.
argue, you always have to call that out. If someone argues, hey, if you're having trouble understand, or if you're having trouble, it's because you don't understand it. But their their requirement to understand it is to have read some 20 books or
Right.
whatever. Well, then they're just being disingenuous, right? Here's the thing:
Yes.
if someone can't explain something, um, like break it down into its parts, right? Especially if someone's claiming they're using the colloquial language, then you need to go through and be like, well, why are you making this sound so complicated? What barrier is preventing you from making this easier to understand, right?
Right. Yeah, and then they'll say, well, like if I use any other language, then it's not gonna hold the same it's not gonna have the same substance or whatever. So I don't know. Like maybe I was just too bored on Discord and I was just listening to him for too long. But I ultimately I'm not convinced by the argument. He wanted me well, I asked him to run it on some like TikTok atheists, but and then he's like, why don't you just run it? I'm like, because I don't know if it like I don't want to get embarrassed. I don't like I don't want to go up there. I don't want to go up there and then throw all these words and then I just get kicked immediately because I'm not like saying anything. It's like and I go, maybe I don't understand the argument enough. Maybe the argument is reserved for people like you that study Hegel or something. But I'm just not ready for the I like analytic arguments. Um so I don't know. There was that. Let me think. Oh yeah. Then there was another thing. Because you remember that reduced row echelon form guy, right?
Rudeau, row echelon. I don't. I'm
The
sorry.
guy that he was like the British guy. He came in here. He was arguing about atheism with you. He used like fine tuning argument or something.
Mm.
But anyway, what's it called? He joined his Discord thing, his room, and he was like, he was talking about what was he talking about? Yeah, he was using analytic philosophy, and they were just going back and forth on terms. And then what the Hegel guy, the guy who made those slides, they basically got to a conversation about how physics isn't like astrophysics isn't even like 100% what's the word I'm looking for? That there's like problems with it, like the way they measure things, like light or whatever, the way they let me just pull up what he ended up
Here. Oh,
saying.
I'm sorry. Four has. I think he may want to
Oh
speak a little bit. Um, but you
yeah,
can
if you want
continue,
to.
Zeno. I'm just letting four has come on
Hey
up.
Zeno, how are
Okay,
you doing?
what's up?
Nothing much. I was listening to this one atheist guy debate with a Christian. It was like this ontological argument for the existence of a necessary being. I'm just wondering what you think of that.
Okay, so you're asking me or Bobby?
You, or either or, whoever wants to answer it, you know.
So ontological arguments usually the issue. I actually don't mind Anselm's argument. I think like things like the modal
That's the
ontological
one I.
argument.
That's the one I heard actually was Anselm's.
Yeah, yeah. I don't like the modal ontological argument because honestly, like number one, you don't even have to accept S5 modal logic. There's people that don't accept that.
Exactly.
Number two, you can run the reverse arguments, which I don't see how Plantinga gets around that. I think Oppie is the one who runs the reverse, and there's no response there. You get the same like logical structure, you get the same being. But I actually do like Anselm's because usually the main objection that people will say, well, I can just say this about like a toaster or something and I can have a maximally great toaster. And
Yeah.
that's usually the problem people have. I say that's fine. You can use whatever. You can use toasters, coffees, like you can say whatever. It's just gonna end up being God. And of course I have to justify that. But that's usually the main issue people have.
I mean, yeah, that's like because the way he was just like framing the argument was like how you guys were saying, like just using really like benign language for the topic, like just using like the absolute most largest word possible to describe like such a simple thing that could be done with like three easier to understand words.
Yeah, yeah. Anselm's argument it can be pretty it can be simplified, I think, pretty well. But it is, yes, ontological arguments do usually face that issue of, well, any kind of like, I don't know.
Any logic argument, any argument that like accepts that you have to like accepts the foundations of logic, like they're all just kind of
Yeah, like
steal.
yesterday I was talking to uh if you guys think that Hegel one, or if Bobby thinks that Hegel one's bad, oh my gosh, I was talking to a guy who considers himself a Deleuze student. And Deleuze is like this French philosopher who really likes Spinoza and Nietzsche. I'm not sure if you guys have even heard of him, but he was LARPing computer science, and that's where I really wanted Bobby to be in, because he would have shit on him. But he was LARPing computer science and saying he uses Deleuze's metaphysics to build some kind of meta ontology and some system using nodes and all this like computer science language. I'm like, okay, this all just has to be LARP. Like, there's no way. He was saying the way in which we crystallize. Like, I'm like, okay, you're just full of
The
it.
way in which
And
they
I
Yeah,
really
you're
want
like,
to.
crystallize.
Yes, he's like, I built this system and it's going to be using these nodes that crystallize. I don't know. It was really dumb. But
Hmm.
anyway, like the point is, it's very easy for philosophy to get off rails. But back to the main question I asked Bobby. Unless you had more.
no, that was all.
Okay, cool. Um, okay, so what he was saying was like the distance ladder calibration, dust extinction models, um, all that stuff. You never test the light interpretation alone. You test it conjoined with a dozen other commitments. So, like dark matter, for example, light is just not like agreed upon. Something like that, and therefore he used that conclusion to reach like, oh well, we don't even know if astrophysics is correct. Same thing with physics. He's like, he kind of shared your concerns about mathematics, like whether or not there's absolute truths. And he's like, look, we can do all the physics we want here, but like, do we really know how physics is going to work, say in Sagittarius A or something, like in that galaxy? I don't know. Like, yeah, he just had a bunch of problems, and I don't know. I just wanted to hear your thoughts on it.
Um, yeah, that's the. I usually bring that up. Um,
Yeah.
yeah, I feel like when philosophers introduce, 20 vocabulary words, they're trying to hide something. That's
Yeah,
what it feels
yeah,
like anyway.
yeah, I agree. The
Um,
Deleuze one, it was funny. The Deleuze guy, the reason they started arguing was because the guy who made those slides, the Hegel guy and the Deleuze guy, I'll just separate them like that. The Hegel guy asked him, "What's absolute difference?" And then the Deleuze guy went on like a 20-minute like rant just trying to explain, and then they talked about difference for like an hour, and I was just laughing the entire time because they're just
oh,
like ridiculous arguments. But you
yeah.
think to yourself, like, I don't know, is there something there, or are they just really like, I don't know? Um,
I mean,
yeah, yeah. Have you heard?
oh,
Oh, go
sorry.
ahead.
For people that are into philosophy, this, a consistency of argumentation and whatnot is of interest, right? Trying to, articulate, knowledge and being and all of that is of interest, right? Um, I always just remember though that like the majority of philosophers are non-religious. The vast majority, it's like 85% or something. And so like for most philosophers, the definitional, progression through the, space of reasoning or whatever, it doesn't lead to a deity that's not held by like any philosophers, right? That's mostly held by Philbro people. Um, and so most of the time when someone is trying to do some crazy philosophical argument, they're trying to deceive people by introducing a bunch of definitions and then telling them, well, if you can't understand it, you're just stupid, and that's why what I'm saying is true, right? And it's like,
Yes.
you know,
Yes.
I don't know. That's how I feel about a lot of those arguments. So I have a tendency to not think about them all
Engage.
that much. Yeah.
Yeah, fair. And maybe it's because I'm young, and I don't know. And maybe it's because I'm young and I'm bored. But it was interesting. It,
Some
it was
people enjoy
interesting
it. Yeah.
listening.
Yeah.
Yeah, even though I don't agree with it. But about the physics thing, so I guess that's why you're like, there's a math question I had to hold on. There's like a million things racing through my mind right now. Okay, so what the heck was I gonna ask? What the hell was it? Oh my gosh, it's not coming to my head right now. But have you heard the ontological argument, like Anselm's?
Um, I may have. Why don't you teach me it?
Okay. I haven't ran it in a while, so hold up. Let me pull up my notes here, because I have like a little debate thing whenever let's see. Okay. Where is it? Anselm. Looking for the Anselmian one. Give me a second. Okay. Okay. It basically goes like this. It is a conceptual truth, and this is just from the internet, Encyclopedia of Philosophy, if you want to look at it too. It's a conceptual truth, or so to speak, true by definition, that God is a being than which none greater can be imagined. That is, the greatest possible being that can be imagined. God exists as an idea in the mind. A being that exists as an idea in the mind, and in reality is, other things being equal, greater than a being that exists only as an idea in the mind. So, for example, usually the example here is like if I have $100 in my mind, Well, a greater being than that would be 100 actual dollars. 4, thus, if God only exists as an idea in the mind, and we can imagine something that is greater than God, that is, a greatest possible being that does exist. 5, but we cannot imagine something that is greater than God, for it is a contradiction to suppose that we can imagine a being greater than the greatest possible being that can be imagined. 6, therefore, God exists.
Okay, you're gonna have to do that again. Go
Okay.
through it step at a time.
Sure. Okay, 1. It is a conceptual truth that God is a being than which nothing greater can be imagined. That is the greatest possible being that can be imagined.
So we're presupposing that there is a thing called God that's the greatest thing.
Not presupposing, but there exists some greatest possible thing.
There exists a possible greatest thing. Okay.
Yes, there's something that there's something that can be the greatest possible thing, and I mean you can just do that by, like, if you imagine, I don't know, if you imagine an island, you can imagine a greater island, blah blah blah.
Okay.
God exists as an idea in the mind, so in the same way Superman exists in your mind or something. A being that exists as an idea in the mind, and in reality is, other things being equal, greater than a being that exists only as an idea in the mind. Thus, if God exists only as an idea in the mind, then we can imagine something that is greater than God, that is, the greatest possible being that does exist. 5, but we cannot imagine something that is greater than God, for it is a contradiction to suppose that we can imagine a being greater than the greatest possible being that can be imagined. Therefore, God exists.
I'm not sure how we got the God exists part out of that.
Okay, because if you imagine, yeah, sure.
Yeah, no, explain. Yeah, tell me.
Okay, so suppose you imagine a greatest possible toaster. Your toaster would end up just being God, because in imagining a greatest possible toaster, you would imagine, I don't know, that it can fit more pieces of toast. It would be larger, and it could, I don't know, provide toast to everybody in the world. It could, you could imagine that this toaster, I don't know, it just provides toast to everybody in the universe, and eventually you would add so many positive, like, attributes to it.
Sure.
It's bigger.
So
it has a mind that can provide toast instantly whenever you want it.
Sure.
Whatever. It would just end up being God.
Yeah, but how did we get that? Therefore, God exists. Like, why did we get therefore
Sure.
God exists?
Because if we have this greatest possible toaster in our mind, the only thing that would be better than a possible toaster in our mind that's infinitely great would be one that actually exists. Because having existence is a greater property than not. Example with $100 that I gave you. Yes. So if I say, hey, I'm gonna give you 100 imaginary dollars, and you're imagining, well, the only thing that could make that better is if I made that actual $100 exist.
How do you evaluate that something existing is better than something not existing, though?
Because the $100 example is usually the one I go to. But if you want further,
but that's an appeal to something that human beings want, right? If you replaced $100 with something that humans don't want, like, what's better, that your house, the floor in your house is covered in shit, or that you've only thought the floor in your house is covered in shit? Like, what's better?
Okay,
most people would say the thought is better than the actuality of it, meaning that some thoughts are better as thoughts than they are as existence, right? And so it's not true that including existence is always going to lead to something being better, because we have examples that that's not true.
Yes, so the floor being covered in shit has negative properties not consistent with that of a greatest possible being. So
I
It,
mean,
it,
okay,
it
says you, sure. I mean that it
well,
seems like what we're saying is so we're going to limit our deity now. Our deity is not the greatest possible being. Our deity is the greatest possible being consistent with what we believe is good, or, in other words, we're going to define, we want the greatest possible being that is consistent with existing being better than not existing. That, in other words,
well,
that's going to be part of our assumption, right?
well, kind of. So we can say that we can say that something has a negative property just via like the I don't know, like it brings some dissatisfaction. And yes, admittedly, that is going to require an observer or some kind. Um, Particularly, the only type of observer we know of currently is humans.
Mm-hmm.
So like with a conscious experience or something. So therefore, we can make the argument that some kind of some kind of being with only positive properties exist, just off the basis of the, we're the only observers that we currently know of. So I mean, unless there's observers out there that only like negative things or something, um, and it
I
seems to us that to our best information, then this is what we can conclude.
well, I again, I so okay. The you analogized that if you were to try to do a toaster, the toaster would become God according to the argument, right? Or that if you did a,
Yes.
baseball bat, it would become God or whatever according to the argument. And the reason is
Mhm.
because the deity is something that has infinite properties or whatever. It's the greatest thing or whatever, right? Um,
Mhm.
the point is that the greatest thing is effectively undefinable, and hence, if I ask the question, does it have negative properties that would prevent it from the fact that existence is more better than non-existence, right? That has to be demonstrated, and one way to get around that is to simply include that in the definition of the deity. The deity is defined as the greatest thing consistent with that existence would be more valuable than non-existence. And I don't see how you can get around not including that. I feel like that's a requirement. You have to include that as part of the definition of the deity.
Well, so it's in the definition of greatest, right? Because if like again,
Okay.
if I just imagine the greatest island, and I tell you, oh, this island exists, but only in my mind, well, then you're going to be disappointed. But if I tell you it exists actually, and that you can go to this island and get unlimited coconuts, unlimited trees, unlimited dancing, like bikini girls, whatever, like
But but
you're
what's
gonna be more
yeah, but
inclined to believe that the
you
actual
keep
island is greater.
but you keep picking benign things. Like, what is the greatest floor covered in shit? Like, what is the greatest floor covered in shit?
Well, I mean, covered in shit is inherently negative because you could get sick from it or something. So, I mean, unless you redefine
I
the shit to be
agree,
like
because it's
healthy, yeah, unless you like make you can make the shit. Okay, imagine the shit like provides, I don't know, some kind of health benefit to you. And then
uh-huh.
okay, then that's a better possible shit. And now say the floor okay, now we have this shit that is extremely healthy. And now
Mm-hmm.
okay, let's make this shit accessible to everyone. It's infinitely large or something. And then we just add more properties. Oh, it has a mind that it provides you like we yes, the floor covered in shit could eventually become God. Yes.
Oh, okay. I don't know. I feel like it's very clear, because the one of the properties that you're assuming that the deity has is that existence is better than non-existence, and we can see clear examples that that's not true, right? And so how do you determine that that is true for the deity I feel like you have to include it as a property. Now, you're saying that you include it in the greatness definition. That's fine. You can include it there instead. But the point is that that has to be included. And the problem is, the moment you include that, you've already conceded that you've assumed what you're trying to show. And that's the only reason I'm bringing that up. Like, you've assumed, like, you define greatness to mean that existence is better than non-existence. You've defined that as the property, part of the property of greatness. And I would then have to argue with you and say, hey, why are you taking that as your definition? Because we see clear examples that that's not true, right? Like, why would we think that that should be part of the definition? And I don't think it's justifiable. I think you just the only way to get through the argument is to assume that that's what it
Well,
is.
Well, what I would say is, like, okay, sure, existence taken on its own, sure, yeah, like, right, you can't make a case that that's just inherently better than non-existing, because then we could just put in, I don't know, some demon that eats all of humanity alive, and well, if that existed, it'd be better. So therefore, the demon is like bad or something. That that that's fine if it were taken to be on its own. The point is that existence, in conjunction with all these greatest possible facts or these greatest possible properties,
Mm-hmm.
would be a better being than existence by itself. Of course, you take any of these properties by themselves, and it's not going to really mean much. You could take, I don't know, infinite mind by itself. That really doesn't do much, because this infinite mind could be evil. But when you take an infinitely good mind or something, um, then okay, it becomes better. And then now you add this conjunction of existence, and because the other parts are also positive properties, the being is good. I don't think I don't think anybody, if offered this infinite, like, I don't know, this infinite island or something, I don't think anybody would deny it, if it actually existed. But of course, if you attributed negative properties, then of course existence would be worse. But the point is that this being is made up of positive properties.
Um. Okay, sure, but I feel like you're just making it. You're just adding in more assumptions, which is one, existence is better than non-existence for things like the deity, and then two,
Existence with positive properties is better than non-existence.
okay, thing with positive properties, and two, deity only has positive properties, right? And hence, definitionally, will be consistent with the assumption that existence is always better than non-existence for things with positive properties. And I'm just pointing out that that doesn't seem to be automatic. Like, those are additional assumptions, and once you add those into your list of premises, this seems to demonstrate that you're assuming what you're trying to conclude, because you're trying to conclude, right, that the deity literally exists, but you assumed that in order for the deity to exist, you assume that the deity must exist because existence is better than non-existence, and you assume that your deity has that property, or you required your deity to have that property automatically, like, definitionally. And so, like, you effectively define the deity to require that.
Um, yeah, I know we're getting like kind of we're starting to get a little circular. So if you want to like move on,
Sure. Let's see.
up to you.
Richard Pryor wants to come and chat.
Okay, cool.
Hey man, how's it going?
Hey, how's it going, Rich Pierre? I was listening to what you guys saying. I don't know anything. I'm a LARPer, but I just wanted to kind of like add my 2 cents to what Zion was saying, because I think the issue, is it Xenon?
Zeno.
Xeno?
Yeah, Zeno.
Sorry about that.
No, you're good.
Yeah, I wanted to add my two cents to that, because the way I'm kind of reconciling what they're trying to say, wherever he read it from, is essentially humans define what is optimal. And like most creatures do that as well. They define like the optimal state of being. So like we could use, for example, currently artificial intelligence, for example, like um, you're in the math space. So for some people, math is a form of God to them, right? They see math as kind of like this way it kind of defines everything and it could solve every problem. AI is essentially made up of like
Well,
math.
not every problem.
And
Not every problem.
we sure, but what I'm saying is some people believe that, right?
Yeah,
And
okay. They'd be wrong because of
wait,
kernels and
let me finish.
complexity.
Let me finish. Let me
Okay,
finish.
sure.
Because I'm pretty much I'm supporting what you're saying.
Okay, cool.
So ultimately, I can see a world where in the future, some form of AI becomes some sort of deity for humanity, and that being because humans are guiding process of the AI development based on the most optimal version for their experience, right? So the definition that he's providing kind of says like, hey, humans come up with the words, humans then define what is optimal. So, like you said, oh, a floor of shit. Well, let's say that shit was a form of manure that provided cures, food, all kinds of stuff. Somehow we made that manure into a sentient being. That sentient being then becomes like multi-universal, whatever the case.
Mm-hmm.
We define those supporting factors that then lets us justify it as being a god. That's kind of what I'm gathering from what he's saying. So
Mm-hmm. Yeah,
Um,
I just feel like at some
my
point you're either destroying the properties of what it was. Like it's no longer shit if it has those properties, right? It's, it's something else, right?
exactly. That I think that's part of what the definition. It kind of recursive, obviously, but I think that's what the definition suggests. Like human beings create whatever the reality they want to be is, and that's where I think you're having the issue of, well, he's saying exist. Like, well, humans define what quote unquote exists technically. And I know we could get into the scientific method and defining blah blah blah. But that's kind of where I think the disconnect is. Him saying the God quote unquote exists when really exist is something that within the world we exist in, human beings even came up with the definition, right? Like outside of let's hypothetically say, because we talk about there being possible other dimensions and black holes going to other universes. In another universe, who's to say that our definition of what we call exist even functions as a thing? So that's where, like even questioning that breaks down.
Well, okay, this is where I can get into a little bit of epistemology, and I could say like, okay, sure, I grant that yes, there could be some alternate universe, but what we know for sure, we can be skeptical of a lot of things. What we know for sure is that we experience things, so we know that experience is part of the universe, our experience specifically. That is like one of the only things that's agreed upon that we can know. Our experience is part of
Right.
the universe, therefore our experience, or sorry, our experience is something real, and our therefore our experience is part of the universe. You could be skeptical about other universes. You could say there's a billion more universes and you're just as skeptical on each of those. However, because we know our experience is part of the universe, now we know that our experience has some like ontology there. We know that we can make a priori arguments because of experience. And I guess that's where the entire efficaciousness comes from. And when people say, oh, yes, but you're using your experience, yeah, sure. Experience is the only thing that we know, really, or one of the only things that we can know. So that's why I think experience is important. But of course, people can disagree there.
Yeah.
I don't know. I like Bobby, and of course, like we're not. I'm arguing this way because I'm defending the argument, but of course,
Sure, sure.
yeah.
Yeah, I feel like there's a hidden. I feel like what was snuck in there was an assumption of the deity already existing, and I feel like it's a sneaky assumption, right? But
Well,
it feels like it's in there because it feels like when you get to the specificity of these definitions, there's some assumptions and some requirements that lead to pointing out, oh, you're assuming the deity exists. That's part of, like in other words, like I can define the word God to mean the Christian God that exists. So I define the word God to mean that, right? So I just define it to mean that. And then I argue with you and say, so therefore the God exists, right? Because I defined the definition to require that. And that's obviously not a good argument, right?
yeah, well, that's where I would bring the arguments back to epistemology and just say, well, like unless you can demonstrate that you defining that actually means anything, then sure. If you can define that the Christian God exists has any meaning, then sure, I can agree with you. But the point is that I can give you a basis upon which I have some ontology, e.g., greatness. If I say, what would be greater, me punching you in the face, or or every punch that I have providing some kind of health benefit to you, that would
But
eventually make you like Superman or something. Like you can measure that based off experience.
we just went over, right, that your definition of greatness included the assumption that specifically talking about things with only positive attributes are
Yeah.
guaranteed that existence is specifically greater than non-existence. So the point is that you didn't just give me the definition of greatness, you gave me the definition of greatness with baggage attached, right?
Yeah, and I guess where I would say is, okay, can you show that great or that not existing with only positive properties is greater than existence? That's where I guess I would, if I want to be
Well,
annoying, that's
no.
what I would ask.
That's equivalent to saying, well, can you demonstrate for me God doesn't exist? That's
Well,
equivalent to that, right?
okay, okay, well, so I gave you an example of like if $100 existed, but if $100 only existed in your mind, the only possible great factor you could add there is it actually exists. Of course, in like this example, of course, this $100 isn't God, right? But like what I'm saying is existence, as far as we know,
Mm-hmm.
when only positive properties are attached, existence, as far as we know, is a great factor whenever it has those positive properties. So I'm just saying
Mm-hmm.
that whenever you have only positive properties, everything as far as we know, if it existed, would make it even greater. Like I can't
Mm-hmm.
think, and maybe I'm not understanding you, but I can't think
Mm-hmm.
of an example where somebody offered to me, hey, I have two things. This thing with only positive properties, let's say it makes you okay, not unlimited amount of money because like of course that would break the economy or something. But like just hypothetically, unlimited money, unlimited food, unlimited resources, unlimited life. You could have this thing, but it's only going to be in your mind, or you could have the same thing, but it actually exists and you can do things with it. Of course, I'm going to take the latter. Like I just can't think of an example with something only having positive properties that would not make it better if it existed.
Yeah. Um.
Sorry if I misunderstood you or something, but
Yeah, I don't know. I feel like I mean maybe we're
you can
just
say I'm being
conflating the
stupid. It's okay.
definitions. Like, uh, now you're saying now you're doing a comparison of only positive properties, something that has only positive properties. Can you give me an example of something with only positive properties?
Um, I can give you examples of things with majority positive
Oh,
properties.
I agree with
Like for
that.
example,
Yeah, I agree with that, but you can't give me an example of something with only positive properties. Like you even limited
well,
yourself
except
immediately.
I could say God, but we're not there yet. But yes.
Yeah, but you even limited yourself immediately where you were like, okay, money, and you started putting it on a scale and then you realized, wait a second, I can't have it infinitely increase, because then it does something worse, right? And
So
so
the reason, oh, sorry, go ahead.
yeah, so I'm not aware of anything that has only positive properties.
Yeah, so we don't need like something actually only having, or we don't need to measure something with only positive properties. It'd be like me saying we need to actually be able to measure infinity to to take a limit or something. We just have, but we do have some kind of scale, like you said there, in that we know, okay, there's these positive properties and there's these negative properties. We seem to like the good things, and whenever things have more good in them, it seems to us that it's better than for them to actually exist. Okay, well now let me measure something that has only good positive, or sorry, only good properties. And now, if that, and because I know that things with more positive properties are better, and things with a lot of positive properties that actually exist are better than things that have more positive properties but only exist in the mind. Therefore, I can conclude that the thing with the most amount of positive properties, or only positive properties, is going to actually exist.
Can you reread the initial definition? Because I feel like there's a lot of drifting going on from the initial definition.
Let's see. Oh, someone wants to join.
Hello?
Hello. Is it working?
Hey.
You guys can hear the guy on TikTok?
Yes.
How's it
I
going?
can.
I'm here to debate. You ready to debate?
Oh, well, let me if that's okay, Zeno, I'll go ahead and let
Yeah. Sure.
the other interlocutor
We're just
join.
going in circles, so it's fine.
Yeah, no worries. Okay, hi, Cal. How you doing? Yeah, would you like to discuss something?
Yeah, I am against leftism and liberalism for one particular reason.
Okay.
That would be the elastic evil argument. Are you familiar with it?
Not aware of it, no.
Yeah, so the elastic evil argument refers to when leftists take the entry point of evil and lower it really low to basically a category, but want the social punishment to be calibrated to the severity of its original definition. You can see this indexed to like racism, where they'll include implicit racial biases, microaggressions, stuff like that. But they'll want the social punishment to be calibrated and correspond with its original definition of a person believing actual racial essentialist beliefs.
Okay, can you make that easier to follow?
Okay, do you think racism is evil?
Yeah, I don't think it's a good thing.
Okay, but is it evil? Is it wrong?
Yeah.
Got it. So it's wrong. Is it wrong all the time? Is a person who's racist evil and wrong and immoral all the time?
I mean, I guess. I don't know.
Got it. Well, leftists... Yeah, so this is where we are. Yeah.
Well, we could come up with elaborate trolley problems, like, if you're racist but it saves 10 people's lives, should you do it? Well,
no, it isn't even... That isn't even the argument. It isn't that.
Okay.
The argument is when they lower the entry point... when they lower the entry point of the evil to subconscious like reactions, right? To implicit biases which are unfalsifiable, but they don't want the social punishment to correspond to the crime, to the entry point.
I'm not sure exactly what you're trying to get at. I was throwing you a bone that, like, philosophically it's not possible to have like an absolutism, like racism is always wrong, because someone could put you in a situation of, like, you know, say something racist to this person or these 50 people will die. Well, it seems like obviously you should probably... Did he run away? Well, fuck you, piece of shit. Wow. Well, okay, that was short-lived. I don't know what to say. That was dumb. I was trying to give him a bone. He sounded... Because did he not present an absolutism? He said, do you think that racism is always wrong? And I was like, yeah,
Yes.
sure. But he's like, well, no, but it's absolutely always wrong. And it's like, well, I mean, I don't know. I'm sure we could come up with a scenario where I guess maybe it's necessary, right? But, like, and I was throwing him a bone. Like, you could give me a trolley problem or something. I don't know, right? Like, it, you know, I don't know. That just seemed like kind of weird. What did he want me to say?
That could even... I could even like take his position for him. What he wants to say is that racism in every possible case would still like demonstrate some level of wrongness. We can measure like, okay, if racism's going to be wrong, or racism in virtue of saving 10 people is going to be the correct thing to do, but it's still going to exhibit some level of like quote unquote wrongness. That's what he should have said, but I mean, okay, he got spawn killed by you. Good stuff.
I guess. I don't know. I thought I was being very nice, but he seemed like mad or something.
Yes.
But I don't know. So you never know the kind of characters you're gonna get. But that's cool. So he was able to join. You guys could hear him, and he could hear you guys. So
Yes.
that was cool. I like it that everyone can hear each other. What I need to do is add.
I remembered my math question, by the way, if you want to.
Yeah,
In like
yeah,
5
yeah.
minutes.
We can do a math question. Yeah, that'd be great. I need to
Cool.
I need to add it to where it shows all the bubbles next to each other, because then if everyone's looking at my screen, people would feel like they're actually talking to each other, right? Um,
Yeah.
I haven't done that yet. So
Maybe
Zeno.
like 5. Yeah, what's up?
If you, but those like ontological arguments, like, do they have any grounding outside of logic, like logic
I don't think
system?
I don't think anything has grounding outside of logic, but
When it like aims of God, so like when somebody
you're cutting out, by the way. I don't
called
know if
like
that's me.
yeah, four has
instead of like
your mic.
Poor House, you're cutting out really bad.
You're disconnected. You're going through a tunnel. You're underwater.
I'm underwater, I'm dying. Wait, is it fixed now?
That came through clear.
Yes.
Yeah, okay. I was gonna say, like, why don't people, like, when somebody brings up an ontological argument, just like refer them to Gödel's incompleteness and just say, like, well, this argument means nothing.
Well, Gödel's incompleteness only applies to arithmetic and in first order logic. So there's plenty of systems in logic that are both consistent and complete. Geometry, propositional logic, commutative algebra, like there's a bunch of them, and they're all consistent and complete. Some of them are zeroth order logic systems, some of them are first order logic systems. But arithmetic, that's where you get screwed over, right?
Wait, why is that so? Like, I haven't really heard a lot about Gödel's incompleteness, though. It's the one thing.
I've tried to give this explanation a few times, but let me try and do it again and see. My explanations, I think, get better as I explain it more.
Well, yeah, it's
so the way logic works is you have a logician, right? And
Yeah.
they're talking about logic or whatever, and they're trying to describe it for you. So what they're going to do is there's going to be a box, right? And they're going to call it logic, right? And then they're going to be very precise and put stuff in the box. This is like the objective, right?
Yeah, exactly.
And so what goes in there are like symbols, or
Like truths, like this symbol will always mean this, like statements sort of along those lines.
definitions, yeah. Or they'll say modus ponens, and the point is that they define how the box works. So there's a sequence to this. First, they define a collection of symbols called a language. They then define
Yeah, exactly, like a truth-finding language, or like a TFL.
Well, the first just the language. I just need the symbols. Then I have to define what the sentences look like, and those are called well-formed formulas. Then I have to define what it means to do inference, or what does it mean to do proof, or what does it mean to call something true. So we define like an axiom as being true, and we define derivations of axioms as being true. And so the point is that the box is filled with this stuff, and you are going to make statements about it. Like, you're going to be looking at the symbols inside of it, and you're going to be like, oh, this thing is true.
Oh, look.
And it means that this other one must be true because of this, right? And so you're going to make,
Exactly.
you're going to make inferences about the stuff that's in the box because you're out here outside of the box, right?
Yeah, you're
that-
perceiving the box.
Mm-hmm. And so that works perfectly fine for propositional logic or other logics, right?
Analytical, or no?
No, just propositional logic.
Okay.
So when we go to do arithmetic, right?
Yeah.
We run into a bit of a snag, right? And so what is the snag? We're trying to do the same thing. We're putting stuff in the box, right?
Exactly. Yeah.
And then Gödel said, well, one of the things that we can do when we're looking in the box is we can list all of the statements in the box. So for example, right, and we can do the same thing with propositional logic too. So this isn't special to arithmetic, but Gödel pointed out, well, the statements in the box, they can be ordered because the symbols can be ordered, and hence the sentences can be ordered, and hence I can order the statements about arithmetic in the box. And so we could imagine that we're just sitting here and we want to list all the true statements in the box. We go, hey, this is a true statement that's in the box.
Yeah, like 1 + 1 = 2. That's like true, like proven
that's
true.
And it's in the box.
Yeah.
Yeah, it's in the box. And then there's also the statement 2 + 3 = 5. That's in the box. It came
that's
from
in the box as well, yeah.
Right? And then we go down and we're like, oh, there's this other theorem in the box, right? And we start listing all the theorems, n times n plus n minus 1, n minus 1 over 2, right? And then we keep making these statements and we're like, hey, here's all the theorems, right? Here is the true
The list of true theorems proven by the math axioms.
Yes.
Yeah.
Yes, exactly. And so what Gödel pointed out was these things are true and they may have proofs with them. They will have proofs with them if they're derived, right?
If they're true, yeah.
They're going to have some proof where like these logical statements, they're the ones that they were used in this order and they proved this theorem, and then the
and they proved and it's like it's like this self circle of proving like it's like I've seen like a lot of the newer math theories are like using Raymond's theory, this is true, or using RM, like stuff like that, right?
Sure, but let's just get through the thing here. So Gödel noticed something, which was that the symbols are finite, the symbols are countable, the language is countable, the list of the theorems is countable, the proofs are countable, and in particular, there's a way for me to encode all of this stuff, right? And so Gödel literally said, well, why do I have to care about these symbols? Why can't I just list them out and just write down their number? So like all of these symbols are really just a number, like 5862. And the proof of them is 7891. Right? I don't know what it is. Right? We can encode this all like in a computer, right? And then this one is
it can be written down.
7823. And then this one is 5931. And then this one is, whatever, right? And this one is 15,782. And the point is that the entire stuff in the box could be encoded to just be numbers. And then Gödel realized something very important, which is, well, if I just have relationships of these numbers, couldn't I figure out relationships between not just these numbers with themselves, but like the
numbers outside
that are listing them?
Oh.
So these numbers here, they weren't in the box. They were the numbers that the guy was speaking when he was talking about the theorems in the box. Right?
Oh.
Like the mathematician is talking about the numbers in the box. The mathematician is saying that's the first number, that's the second number, that's the third
Yeah,
number.
yeah.
And so this seeming part over here was not part of the box, but it appears that because these are pure numbers, there might actually be relationships to these numbers with respect to those. Like, for example, there's some set of these that might be the numbers where every number that is true, its proof is double itself. Like that could
Yeah.
possibly be a thing, right? I don't know what number that would start at, but there could be some in here who are their proof is the double of them, right? That could be the case.
Yeah.
And those numbers would have their own special sequence. So there could be a sequence of numbers here that have some property that relates these together, right? And the point is that Gödel realized that he could demonstrate, hey, there's going to be some number, whatever it is,
X number,
that,
hashtag, yeah.
yeah, whatever. I don't know what number it is, but it will effectively have the property, and we don't know what, I can't tell you what the numbers would be because we'd have to construct all of this, right? And
Yeah, you would
this
have to
is
construct a
this
whole
is
math set.
yeah, this is a very long amount of construction because you have to construct what it
Yeah.
means to prove, and you got to construct this and that. And
Yeah, yeah.
Gödel spends a lot of time on his Gödel numbering to demonstrate what relationships you can tie back to the numbers that are being spoken by the mathematician. And the point is that you can, every statement you make about these numbers, that's the important thing I want to say. Every statement you can make about these numbers must also be a statement about numbers. So, like, for example, if I said some of the even numbers have a proof of 1, 2, 3, 4, 5. So this statement I made is outside the system, and it's about these numbers.
Exactly.
Right?
Yeah.
This is
Yeah.
a statement about numbers. So this statement is a number. I don't know what it is, but it's in the list somewhere, right?
Oh,
Because
so
it's,
it'd be like to get every single statement because we don't know every single statement.
but we
But
said we did. We said the box contains all the statements about numbers. We said all the statements about numbers are in the box. And then Gödel's
oh,
like,
yeah, yeah.
well, here's a statement about numbers. It's about the numbers outside of the box, but it's a statement about numbers. Well, then it must have
Numbers.
a number that's in the list somewhere, right? And so the point is,
Oh, yeah.
right? The point is you end up with this circularity where every statement you could make about these numbers must also be in the list somewhere, right? Or every statement you
Yeah.
make about the proofs is able to be tied to this somewhere. Or this,
Yeah,
like,
this
the
somewhere.
point is he gets these to talk about each other, and effectively he demonstrates that you're guaranteed to find a number where that number is a theorem, i.e. is true, like if and only if it has no proof. Now, the
Oh.
exact construction of this is tedious, and it deals with this recursion, and he ends up with a recursion where he's guaranteed that this must happen at some point, that there's going to be some number where he
Number.
knows, and these statements in here will be about that number. That's what makes it tricky. And but it
Oh,
happens,
because he's
right?
referring to a number that's outside of the numbers,
Yes,
basically.
yes. I mean,
Yeah.
it was supposed, yeah, it's outside the numbers, but we said that all the statements about numbers are in here because that's how we define the axioms. Like, we declared this box contains
Yeah.
all the true statements about numbers, right? And so the point is, once he has this basically stated, then he now has a problem because he now
Logic
just
can't
found a
prove this.
statement. He just found a
That
statement
hasn't.
that doesn't contradict any of the other statements. But if the statement is true, then it can't have a
Then it's
proof.
no
There is
fault.
no proof for it. and
Yeah.
hence he demonstrated Gödel's incompleteness theorem, and so Gödel demonstrated, you know,
That math is incomplete in some
that
way.
arithmetic is incomplete. So arithmetic will
Arithmetic.
yeah, whatever. Arithmetic always has a true statement
With no
right,
proof.
that cannot be proven. Yeah.
Or yeah, that cannot, yeah. So he completely crapped on that one guy. What's his name? Pinon's axiom? He just
not piano. No. Piano is just an arithmetic system of axioms. In fact, that's, I think, the ones he used.
Wait, Gödel used the ones
I
with
think you're
piano?
thinking of Russell. I think you're
Oh,
thinking of
Russell. Yeah,
Russell.
no, it's
Russell was destroyed.
Yeah, it's
yes,
100%.
yes. Russell was destroyed.
That was Russell. It wasn't.
Yeah. So this breakdown is tricky. How he breaks it down this way, and what properties he derives. But there's like a whole, like, if you in any good logic book that goes over Gödel's incompleteness theorem, they'll have a whole chapter on all the different things that you can demonstrate. So you can first demonstrate that, like, certain even properties are able to be found and certain odd properties are able to be found, and then you're able to demonstrate more complicated things, like anytime I have a function's proof, I'm able to find the proof for the Gödel number of that number, right? And that will be in the list somewhere, right? And so then he keeps doing that kind of stuff, and then at some point you end up with, a theorem that's along the lines of, and I forget exactly what it is, right? But it's a fairly complicated recursive thing where, like, there's guaranteed to be numbers that talk about themselves in this particular way, so that, like, a number's statement will talk about its own number that it's in the list of, right? And that's just going to be weird that you have a statement that talks about itself, and eventually he derives this particular one, which it doesn't say this in words, it says something else about numbers, right? But the equivalent of it is, this statement is only true if it has no proof, right? That's what it is. And so once you have that statement in the list here, you now know that that arithmetic is incomplete. It has to be incomplete, right? There's no way around it. And so the reason that Gödel's incompleteness theorem goes through is because arithmetic is the assumption that arithmetic works, right? Or that everything in arithmetic is true or whatever, right? And so if you don't have the assumption that you have all the true statements of arithmetic, like, you don't assume that, then this won't magically break your system, right? So.
Yeah. Well, yeah, but if you assume that everything in arithmetic's true, then this is, like, completely destroying your system. Yeah.
Yeah, we're kind of jumping around the vocabulary, and we have to be a little careful. I mean, technically, we're putting statements in the box. We don't know if they're true and false yet. There's little nuances I'm kind of skipping over, but effectively, yes, that's the way that's the way it happened, right? Is we're talking about statements. Some of them have proof, some of them don't. The ones that have proofs, those would be true statements. The ones that don't, they may be true, they may be false, right? But the point is that all of arithmetic is in the box. Whether you're talking about the true statement or the false statements, or how to figure out the true statements, they're all in the box.
There's like
it's all there, right?
There's like this logic class that my university offers. It's literally called Gödel's incompleteness theorem. And I was just, like, thinking about taking it because I just did logic.
Yeah. Well, I'm sure.
You think it?
Well, it's going to go.
Is it difficult?
This, right? It's going to.
It's going to go over this.
Well, this is Gödel's incompleteness theorem. Gödel's incompleteness theorem it's pages of this. He goes over this in rigorous
Yeah.
detail. How to
Is it like a
do
whole book?
numbering. Normally it's a chapter in a book, right? Yeah.
But it's like a whole class on just Gödel's. It's like
You
fully.
could-
It's literally just.
It depends. I mean, so when I took logic, the main course, the reason for the logic class, the reason we were there, was to learn Gödel's incompleteness theorem, right? So we spent weeks learning all the other parts of logic, right? And then the last month or two of the class was dedicated to Gödel's incompleteness theorem. But that's true of almost any book. Like, I have Hamilton's Logic. The beginning of the book, the first 4 chapters, are dedicated to teaching you what logic is. Like, what is logic, right?
Yeah, exactly.
And
It's like
then,
just what is logic.
yeah, and then the last 7 or the last 3 chapters or something, that's completely dedicated to
Just the Gödel.
Gödel's incompleteness theorem. Yeah, Gödel's incompleteness theorem.
Yeah. Dang. I kind of want to take it. It seems really interesting, actually.
Yeah.
And then what's the Raymond's? Like, that's like the prime numbers have a wave that goes like forward and back, right? Between the Raymond hypotheses?
What? Raymond's?
Raymond?
Riemann hypothesis.
Riemann
Riemann.
hypothesis. No.
Oh, we're up at a new page.
Okay, so Riemann hypothesis is.
Oh yeah, it's the zeta function.
It's the zeta function, yes. So here, so this is a complex variable function. It's a special function. This particular representation is called a Dirichlet series, so it's a special type of representation. The zeta function has many different representations. This is not the only one. There's other ones that are integral representations, right? It's just that this is the most common one that's looked at. So the zeta function is a complex variable function. You plug in complex numbers and you get complex answers, right? So if we attempted to look at the complex plane, we would ask ourselves questions like, well, for what complex numbers do I get, pi squared over 6 or something? So like here at 2, if I plug 2 in to this equation, we get pi squared over 6. We get pi squared over 6, right? So plugging 2 into this turns into pi squared over 6, right? What happens if you plug in, minus 1, right? So if you plug minus 1 into this function, you get negative 1/12, right? And so there's a number that you get for plugging in minus 1, right? If you plug in 1, right, you get infinity. And so that's what we call a pole. And the Riemann zeta function is known to have a single pole in the entire complex plane. That's the only spot that's a pole. There are no other poles. So you might ask yourself, well, what happens if I do this? I set this equation to 0 and I say find all the z. Now, when they did this and they started calculating all of the z's, they were like, well, what are all the z's that make this equation 0, right? And they started calculating them out, and they were like, oh, I found a 0. There was a 0 that was like right there, right? They're like, oh, I found a 0. And it's like, it's real part 1/2, and then it's like plus, 12.87329 I, right? So it's got an imaginary part, but it's got a 1/2, right? So then they found another 0, and they're like, oh my gosh, I found another 0. There's another one like right there. And then it came out to 1/2 plus, 17.2934 I'm making up these parts because I don't remember what they are.
You don't know or remember, yeah.
They're just estimates, right? And
Yeah.
then the famous question was asked, do they all have real part 1/2?
Oh.
And Riemann didn't know. And no one knows. Do all the zeros of the
And no one
Riemann zeta
knows.
function have real part 1/2? No one knows.
Oh, because there's no way to get all the, like, you would have to calculate like so many
Well, no. Think of it
complex
this,
numbers. Yeah.
No.
like for example, do you know sine wave? Do you know the sine wave?
Yeah. It's like
So the sine wave looks like this, right?
exactly
And it goes through the numbers, what, 0, pi,
0, pi,
2 pi, 3 pi.
3 pi, 4 pi,
And so I can
right?
tell you the zeros of
Sine.
of z are, they're all zi equals or zk, let me use a k, 2 pi k, right? Or I'm sorry, pi k. This is what the zeros are, and so I could tell you all
yeah,
the
because
zeros,
I see it.
yeah, all the zeros have an imaginary part that's 0. They don't have an imaginary part.
Yeah.
So all the zeros of sine are real. They don't have an imaginary part, and they're all exactly of this form. So I know what all the zeros of sine are, right? And here, I'm not even telling you to find all of the zeros because no one knows what the fuck to do with these parts. Like, this is just, horrible.
This is just that's like another level. It's like,
but we're at least asking, do they all have a 1/2 for the real part? I mean, one, why do they have a 1/2? That's weird. But two, do they all have a 1/2? We don't know, right? No one knows.
Yeah. And is it provable or no? We don't know.
We assume it's provable. I mean,
well, there's a proof that exists, either yes or no.
We believe it's either true or false. It would be I've spent a lot of time on the Riemann hypothesis. I would be blown away if someone demonstrated that the true, like the answer to this is independent of the axioms of like calculus. I would be blown away if that was the case. Like, you could just suppose it had one that didn't have 1/2, and there'd be no contradiction in mathematics. That would be insane to me. That would blow my mind away, right?
Dang.
So
is it why it's became like foundational now? Because there's theories that use like assuming Raymond's true. Because I see that like
Riemann.
a lot. Or Riemann.
There are plenty of theorems that have been established on the validity of the Riemann hypothesis. Yes.
No, but like after that, because there's like theorems that would say, assuming that this is true, like that this theory is now true, or like an earlier theory was not true. That might no, that's wrong. Not an earlier theory, just like, well, I can.
I'm not sure what you mean. I'm sorry, because like the it is the case. It is the case that theorems have been established on the assumption that all of these are 1/2. So there are other theorems that have already been
that's what I
proven.
meant.
Those theorems would be invalid if it turned out that this didn't have 1/2. Right?
Yeah.
But no one's been able to demonstrate those are false either. See, that would be a way to show it. If you assume these are 1/2 and you found some theorem, and it'd be like, okay, here's a theorem, but then that theorem had a consequence of some other theorem, and then that theorem had a consequence, and then some consequence led to some contradiction, you would then have demonstrated that they all don't have 1/2. One of them doesn't have a half.
Yeah, proof by contradiction. Suppose the Riemann zeta function does have zeros that all contain one
One
half.
half.
Well, then you have to show the contradiction, which nobody can do right now, or nobody has done.
Yeah.
If someone found a counterexample with a computer of where, this is kind of a funny bit. There is a $1 million prize for the Riemann hypothesis. The language in the prize says $1 million will be awarded for anyone who provides a proof of the Riemann hypothesis, right? So some people have read that and said, wait, if I find a counterexample, I don't get the $1 million? And the answer is technically yes, but everyone assumes you would get the $1 million because there wouldn't be
that's funny.
any proof anymore, right? There's no. What are they going to do with the million? Keep
Right.
it? I don't know. So, you would probably get the $1 million if you found a counterexample. But don't fret about that. Don't waste your life. Okay, this has already been verified for like the first 15 billion zeros or whatever. Like they're all one half. That's all we see is one.
What
half.
about when we get like a quantum, like a real quantum computer?
Mhm.
Do you think a real quantum computer could possibly find a scenario where there is a zeta function where they don't have one part real half?
No mathematician would ever accept a proof on a quantum computer. Because quantum computers inherently operate on uncertainty, which is not how mathematics is proven. Could it be correct? Maybe. I don't know. But no one would ever accept a proof on a quantum computer.
Bobby, can we do my math question now?
Sure. Yeah. Sorry. Yeah.
No worries. I know I yap a lot and I talk to you a lot. So, okay. So, over the past week, I've kind of like reestablished or like have been revisiting a lot of what I was taught. Like, I don't know. I just found whenever I DM'd you, like asking the best YouTubers, I found that the way I hate the way math is taught because it's like, okay, here's these calculations, whenever you differ, like if you're doing implicit differentiation and you differentiate y, make sure you put dy dx there to show like, okay, that doesn't build my intuition whatsoever. So I guess my question, like, there's this mathematician that somebody told me about. He has a Fields Medal. His name is Peter Scholze, Peter Scholz, however you say that name.
Okay.
And one of the ways he taught himself math was like completely backward. Like he had the same like itch as me, where it's like, okay, these things aren't really getting taught, and no intuition's being built. I'm going to teach myself like complex analysis as opposed to, doing the baby stuff. Like he went completely backwards. And I guess my question is, can I do that too? Because I want to learn about like complex numbers and all this stuff, but I don't want to do it through like brain rot, high school algebra, or like calculus. Like I want to do it from like how I do philosophy, like completely axiomatic, like give me the first principle stuff so that I can actually build an intuition.
Yeah, I mean, if you want, there's certainly nothing wrong with that. It's when you're in algebra, like beginning algebra, and then you make your way into trig, and then you make your way into pre-calculus, and then you take calculus, right? These are classes that are for a general audience, and more importantly, they cover decades upon decades of mathematics, right? Like
Right.
Newton's entire theory of calculus is nothing in comparison to the amount of calculus we teach in calculus today. The calculus we teach now involves
Yes.
all these other topics, all condensed from dozens of mathematicians over 100+ years, right? With all of these little nuances and all these tricks, And so the point is that when you're in a class like that, there's a lot of dedication to keeping your variables straight, making sure you're not forgetting things, making sure you're keeping things aligned, these types of things, right? And so it
Right.
wouldn't be unusual in a calculus class that your teacher, smacks your hand or whatever. I mean, we don't do that anymore these days. That'd be like assault. But they smack your hand. They're like, "Where's your d? Where's your d over dx? You're freaking screwing with me, right?" And that's what you would
Right.
expect in a
Plus
class
C, you
at
forgot
that
it.
level, right? When you go
Yeah.
into real analysis or something, there, people only care about what's true. No one cares about no one cares about your dx's anymore. I have whole math books that don't even put the integration anymore. They're just like, integral x cubed. And then people are like, "Where's the dx?" And I'm like, "Oh, I don't know. I don't care."
Brain rot.
Like,
Yeah.
because that doesn't matter to me. What matters to me is, the thing. And then you have some books that are just like, "Okay, we're going to talk about changing every function we can think of. And we're going to do it by putting them in as a kernel and then multiplying them by like cosine xt. And then we're going to integrate with respect to x." And so they want to do this to every function they can, right? And when they do this, it turns into a new function called the cosine transform of f. So they give this equation. And then some books are like, "That's way too complicated. I don't give a shit about all this notation. I'm just going to say f of t is called the, Fourier cosine transform of f." And so they just use this symbol. And you're like, "But what happened to the integral and everything?" And they're like, "Well, we're just trying to figure out the properties of this. Like, when I add
Sure.
if I add two of these, what happens, right? Like, I go like this. Like, is that the same thing as, doing the sum? Like, is that the same thing as doing this? Right? And it turns out, yeah, that is true, right? Doing it separate is the same as doing it. What about if I do times? I do the times of them. Do I get the times of this? No. You get some really screwed up thing, right? Which called a...
Is that the product?
Yeah, it would be the product, right? But the product doesn't go through. It turns into another symbol. So you would get, well, I'm going to do the product, but what that's going to turn into is called convolving. So they use a different symbol. They go star. And so if you convolve the functions together, which means you integrate in both directions across the functions at the same time, then Fourier transform that, it's equal to the Fourier transform of each one of them multiplied. And so you can get cool things like this as a theorem, and we're just completely leaving out all the integral symbols, and that's common in math, in higher math classes. They do that all the time, Yeah.
Yeah. So like the point is I'm trying to be a scientist. Like I'm not just trying to, pass the class. Like I want to be able to, I want to be able to leave a class feeling like I could have invented all of that given, it's like I could have discovered all of that myself given the knowledge that was shown to me. Like I want to know the bones of everything that was discovered. Like, don't just give me intermediate value theorem. Don't just give me that. Like, I want to know why that works.
Yes.
And so
that's also a product of laziness, at least for most mathematicians, because they're like, just tell me the one thing I need to know that allows me to derive all the other shit, right? And so mathematicians do that all the time. Yeah. Have you figured out if you like discrete math more or continuous math more? Like,
so yes, that's what I was gonna ask you. Discrete math, I definitely find intuitive way more because like whenever people in continuous books talk about functions, they're just like, oh, it's this thing like one input, one output. But whenever I hear discrete math people talk about like function machines, I don't know why that just makes way more intuitive sense to me.
Yeah. Well, you might like a number theory book then. Like just so the beginning of like abstract algebra or maybe in parallel to abstract algebra or whatever is number theory, which is just the study of whole numbers, like 7 and 17 and 21 and
Yes.
15. And it seems like, well, what could we possibly learn about these things, right? Well, there's actually a lot we could learn, right? So there's a concept called modulating. So, like, if you take 17 and you modulate it by 7, this means to divide 7 into 17 and get the remainder. So you would count by 7, 7, 14, and then 17 minus 14 is 3, and so there'd be a remainder of 3, and so you get the remainder, right? And so modulating is very important. And there's a magical theorem by Fermat, which says that if I take a prime number and I raise it to a power, like 15, right? And then no, sorry, hang on, let me see. If I take a number and I raise it to the power of a prime minus 1, and then I mod by the prime, I always get 1. And
What the shit?
That's a magical theorem. And so let's try one. Let's just try one because it's so fucking cool. So let's take 7 and we'll raise it to the 11 minus 1, right? And so I don't know what that comes out to be. What's 7 to the 10th power? Calculator?
No clue.
Hang on, I got a calculator right here.
Cool.
7 times 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there we go. It's 228,475,249. So that's what it is. And now we're going to take that number and we're going to mod it by 11. So we're going to divide this number by 11 and get the remainder of it, right? So if I divide by 11, I get a bunch of whole numbers, 25,679,568.090909. So this is the fraction part left over, right? And so what is that times 11, right? 0.09. I'm doing decimals, so this is just making it complicated. But the remainder is 1. So let me just erase this. Remainder 1, right? So this was the whole part. So 11 divides into this and gives me this, and that's the remainder. And so this modded by 11 is 1. Now, of course, it's not surprising. I knew it was going to be 1 because the theorem is that it's going to be 1. There's a theorem that says it always is 1. And this is called Fermat's theorem. Fermat.
How the hell did he figure that out?
That is what you would learn in a number theory book. How did he demonstrate rigorously in, when did he live? 1500s? Like 1500s. He didn't even have calculus, right? And he demonstrated just playing around with numbers, that this thing is a theorem. And he was like, holy crap, that's freaking insane, right? And so this is always 1. It's just always 1. Pick any number, raise it to the power of p minus 1, mod it by p, you will always get a 1, as long as p is a prime. And there is a way to prove this. It's actually not that complicated. It requires some steps, though. But he goes through a rigorous proof. And in a number theory book, that's the kind of stuff they would walk you through. What are all the properties about whole numbers that we know? Like, what are all the things you can do with whole numbers? What is all the theorems out there, And this is the kind of stuff that's proven in a number theory book. So,
see, like that's why I guess that's why Gauss called it the what is it, like the Prince of Mathematics or something? Like math is the queen. Yeah, math is the queen of the sciences, and something like that. But it's like I'm very about give me the bones of what the hell I need to know, and then I can deduce everything after that. Like I don't need you to tell me that, hey, you need to memorize that this is what this function looks like, and you need to memorize that x squared plus y squared equals 1 is a circle. Like, no. Tell me why the shit is a circle. Tell me what tell me what these numbers and variables do, and so far as like it relates to a function. And then I can discover on my own that, oh, hey, if I take x squared plus y squared and make that equal to 1, the thing that I'm going to end up getting on a graph is a circle. Not just because x squared plus y squared equals 1 is just some imaginary thing that gives you a circle, or some magical thing that gives you a circle. No. It has to be a circle, because x squared, you can't choose a number like 100 or something. You have to use numbers. You have to use numbers that are less than 1 or whatever.
Yeah.
Or less than 1 and greater than -1. So yeah. But yeah, no. Okay, so I'm ready for number theory, is what you're saying.
Well, if you like this, if this intrigues you,
Yes.
like what are all the whole number
Yes.
things? This number theory is like it. Some people take number theory at the same time as modern algebra, but I think taking number theory is really helpful to understanding modern algebra, because modern algebra, like group theory, ring theory, field theory, all of that is like the modern mathematics. Like it's the final extension of number theory, but number theory is like the beginning. It's like when no one knew anything about numbers. Fermat is sitting here playing around with whole numbers, and like there's all these properties of these things that, and they don't go over this in modern algebra. Modern algebra, when it goes into group theory and stuff, they don't go into number theory. And so if you like playing around with whole numbers and stuff, number theory is just a good class. It's a good class to go take. Yeah.
Yes.
It's
Yeah,
also
makes sense.
it's also highly useful. Not in Fermat's day. Everyone thought he was useless. He thought he was useless, right? But that's because like who the hell would need to know this? Why would you need to know that? That seems
Right.
ridiculous, right? But not anymore. Ever since the invention of computers, all of our cryptography is based on these theorems. This is literally the foundational theorem for RSA cryptography, right? And so that is incredible, right? Yeah.
That has an applicate, right?
That it has an application, yeah.
Yes. Okay, and then yesterday when I was talking to that physics Hegel guy, or not physics, but like the Hegel guy, he was saying that there's a problem in mathematics, and he gave me this YouTube channel. Apparently, this dude's an actual like mathematician, and he has like good publications. But like apparently, there's issues with like, okay, suppose you want to add e and like pi or something, like you don't get anything. You can't do it. You just have to do approximations. Therefore, when it comes to mathematics, we're just doing like approximations, and you can't actually do anything. So he saw that as an issue, and I just wanted to know your opinions.
Well, there's plenty of things that have approximations, but like mathematicians don't care. Like I could give you an exact formula for pi plus e. It'd just be the formula for pi plus the formula for e. Right?
Yeah, but I guess what their issues are is like, okay, but I can't do anything with that. Like it's gonna be some just algorithm that produces infinite like numbers.
Yeah.
I
But
don't know.
mathematician. So an analyst doesn't care. An analyst is like, I define functions, ad infinity sometimes. I do integrals till they go to infinity. Everything's a limit. No one cares. So like,
Right.
So the fact that some numbers can only be understood by considering an infinite sequence in order to get to them, it just means every time I do a proof with them, I have to consider the infinite sequence every single time, right? And so
Right.
that's fine,
Yeah, kind of like with the Riemann thing, like you were like, okay, I don't care about the second half. What I care about is the thing that's consistent.
Yeah.
The other half, I mean, yeah, that goes on ad infinitum, but the half thing, you don't know. Well, yeah, makes sense.
Yeah, the half is just so weird. Why did it come out to a
Right.
half? right? Now, there are reasons, like there's a reflection principle that occurs with Riemann zeta type functions. There's a whole class of these, and all of them reflect on the line itself. They reflect on the 1/2 line. And so there's something weird about the integral reflection and the fact that
What
it
the hell?
reflects around that line, and hence the zeros all have to be on the line, right? But no one knows how to prove that, right?
That's so damn weird.
Yeah.
Okay. So whenever you asked if I like discrete over continuous math, like why, or like what would happen if I answered continuous?
I'm sorry, say it again.
You asked earlier if I like discrete or continuous more,
Oh,
and when I
yeah.
said discrete, you were like number theory, and then what if I would have said continuous?
Oh, well then I'd redirect you to calculus. I'd be like, "Oh, you love integrals and Fourier analysis." If you look at this and you're like, "Oh man, that's so freaking cool. Look at all that calculus and we're completely hiding the symbols and that's kind of annoying." Of course, that's kind of annoys me actually. I like writing it with the symbols because I want to see the integral and I want
Yes.
to approximate it and I want to see my epsilons and stuff. So that's continuous stuff. And there's plenty of stuff in between. There's all kinds of stuff that's like halfway here, halfway there. So there's plenty of math topics. Some people love to go super abstract with math. They don't want to do any of the lower stuff. They're like category theory. Just make everything so abstract it has no meaning, or whatever. Um, that's
Oh,
the
is that
stuff.
like the is that like the remember that one dude like Gizmo or something that was in here talking
Uh,
about I forgot what the hell it was. It was like it was
cohomology
there
and
it is.
something. I forget. All I know is I asked him for the definition and he gave me the wrong definition. And I was like, and
Yes.
then when I said, dude, that's not the definition you gave me, he said, yes, it is. And he did you're just too dumb because you don't know category
Yes.
theory. And it's like, I know I don't know category theory, but I asked you for the definition and the thing says completely different than what you say. So, like, that doesn't make any
Yes.
sense, man. Like, so anyway, that was just
Yes.
a weird conversation. Like, I don't mind Gizmo, he's fine, but he says he's never taken any math, meaning that he's only someone that's read a bunch of stuff. So he's Googled a bunch of stuff and read a bunch of stuff. And so like he doesn't actually know some of these
Credentials, yeah.
things. He just kind of throws out some terms sometimes. And I'm like, well, that's not cool, So
Right. Um the by the way, if somebody else wants to come up, I know I've talked for a long time. Or
yeah,
if you want to
FY
like answer questions or something.
well, just FYI to everyone, if you're in the Discord and you want to chat, you gotta just click the raise hand button, and then that lets me know. And if you're in the TikTok and you want to chat, just do the whatever the thingy is. I don't
Hit
know what it's
the
called.
hit the two people thing at the bottom of your
Yeah, the two
screen
people thing at the
and
bottom, and it does the multi-host thingy, and then you can chat. And I have the audios connected, so you can chat with the people in the Discord, or the Discord people can chat with the people in the TikTok. So it's all connected. We're all big one happy family. So, and I can't do that with Instagram. I'm sorry, Instagram sucks. They don't let you guys talk. So I don't know. Blame Instagram.
there's also a guy he's a discrete math connoisseur, but he's like, oh yeah, slope is not actually rise over run or something. Like can you elaborate on that, because I haven't, I just scrolled past his thing, but
Oh, slopes definitely rise over run. I don't know what that would mean.
yeah, he's saying like it's the change of a vertical line or something like I forgot what he said.
Well, that's just another description for it. It's the rate of change, or it's the derivative, right? But but slope. I mean, I don't know. Slope is definitionally rise over run. That's its definition. Like I don't.
Yeah.
How would you say it's
Yeah,
not
probably
rise
just a
over
crank.
run?
That makes sense. Okay, so number theory, I need to read a book on that. I feel like you're gonna end up making me a mathematician as opposed to a physicist, theoretical physicist.
Well, it depends on how much you love the particle stuff. Like, do you want to be on the board going through the equations of the different particles and trying to resolve them or figure out how they work, right? Like, have you ever watched Big Bang Theory, right? Sheldon was a theoretical physicist. So he was, looking up equations and papers and then trying to figure out what would make them consistent. And then he would work with experimental physicists to somehow come up with an experiment to get something to test something, right? Let's test if this actually does what it seems it does. And that's what physicists do all day long. They propose ideas, they test them to see if they're real, right? They try to figure out how they work, right? Whereas like a mathematician, they're often their made up abstract world outside of when no one cares if this has any application to the real world. Fermat certainly didn't care if this theorem was useful.
Right. Yeah, then I probably lean more towards the former since I don't know. I'm impatient by nature, so like if I discover some math thing, which if I do a PhD, obviously you have to, but if I discover some math thing, I'll kind of have it in the back of my head. How the hell are people going to use this in like 200-300 years? I don't know. Versus theoretical physics, it's like okay, at least the math works. Maybe in like 100 years or something, people will figure something out with it.
Yeah,
Or
maybe.
the experimentalists.